Hey, hello everyone. Welcome to week 6. In this session, we're going to be looking at functions. So we're going to look at more functions today. I want us to begin with this very important topic in SQL, the case statement. We're going to begin by looking at the simpler version, which is this one. So this is a logical function, right? This you're going to use this a lot in businesses. So this is the simple version. This one just takes two conditions and evaluates them. Meanwhile, this one is a bigger one. It can take multiple conditions, right? So we're going to get started by opening this document right here. Case statement, class notes. I'm just going to go to Management Studio, click on the shortcut right here to open the file and simply navigate to week 6, day 1. Week 6, day 1. This right here, case statement. Right. So this is going to evaluate a condition, right? So we're going to evaluate a condition. Usually this is good when you have a condition that has two parts, binary conditions basically. So this segment is very, very important. Please, let's focus on these two. We're going to begin with a simple one. We'll see how it looks like, and then we're going to extend it to the bigger one, which is a case statement. Right. Okay. So in the if function, this is a function right here. If it simply evaluates a condition. If that condition is true, this is a part that will be returned. If the condition is false, this is the part that will be returned. So that's all about the if function. It simply evaluates a logic. That's why we call them logical functions. You have a logic, this is a business requirement, you're testing, you put the condition, similar to the conditions we put in the where clause. You just type in the condition and then you put a true part. What do we get, or what should this function return if this condition is true? That's what you're going to put right here. And then what if the condition is false? This is what we get. So it's a binary outcome. For example, I will introduce you to a table which has a column called marital status. S is married, M is married, S is single. But then in the table, it is uh, given in this coded version, M and S, right? So let me show you. I think I was supposed to put the sample right here. So just add this to the database. The script, this should be on the adventure work. I think this should be the bigger one, right? Yeah, so just add this line on top of that. This is a table we're going to be exploring, the employee table. I'm just going to show you how that table looks like. We can take a look at the column we're going to be analyzing for this, right? So this is the table right here, and the column of interest for this question is this. What is that? Marital status. This one right here. Right. Last time we talked about the data dictionary for this database. If I just go back to week 5 lab session where we saw that document, week 5, the lab session, and I did talk about the Adventure Works data dictionary. So any column you come across in those Adventure Works, you can actually go to this document and explore and see the definition of the different columns. So we're looking at the employee table, and it's found in the human resources schema. That information is necessary. I'm just going to go now to the data dictionary. So we are on the human resources schema and an employee table. Okay. Now the focus, I'm going to move to the column side, and we should be looking at marital status. It's right here. Right. So in the table, it's coded as M and S. Right. This one right here. So, but then if you are to push this document out for others to use it, most managers will want this to be, decoded. It should be more descriptive. So instead of having M and S, you should put the full meaning of those two, right? So in order for you to do that, there's a simple thing in SQL, we call it the if function. This is good because we have just one condition to evaluate, and then we have two possibilities. So instead of showing S and M, or we can do the same for the gender. Instead of showing M and F, show the full meaning of those codes. See that? So it's easy to do this in SQL. We just have to remember the if function. It's a conditional function. It's going to evaluate a condition. In this our case, we just have to test if the marital status equal to M, what should you return? Instead of M, give me married. This is now the true part. So this is a condition we're evaluating. I want to take you back to the syntax. This is it. Put a condition. This is a condition. Marital status equal to M is a question. If the condition is true, this is what you should put. In our case, if it is M, the full meaning is what? Married. That's what we see in the documentation right here. So that's what we're going to return. Right, and then this is now the false part. See, otherwise single. This is a binary column. M is for married, the opposite is S, definitely. So I want you to see how this is coded. This, at the beginning, you might think it is like this. This is something different. This is also a logical concept in SQL. It runs a loop, right? But then what we are looking at currently is the if function. If function. You simply evaluate a condition. It's still a condition. The true part of the condition is placed right here, and the false part. This true or false depends on the condition you enforce right here. Right, so you can switch this. You can test for condition marital status equals to S. Then, of course, you have to switch these positions. See, this is very important. People code this differently, but then you have to respect the workflow. You see, the condition is stated right here. The true part of the condition is what you put right here. And the opposite or the false part is what you put right here. So this is good only for scenarios where you have a single condition that will return two outcomes. This is for binary outcome. There's no option for a third. See, some people use nested if. That's too much complication. If you're dealing with multiple conditions to loop through, I'll encourage you rather to go now for the case statement. See that? So take note, for the if function, you just have one condition evaluating. You have a true part and a false part. End of story. And that's how you're going to code it. So guess what? Since we are putting this logic in the select clause, it means that we are generating a new column. This is now the status description. Remember, in the original table, we had just have marital status M or S. Now we want to add a description to that. Right? And this is it. If you want to do the same, we have a gender column. Gender is also not descriptive. It's just F or M. I want to evaluate the condition and then return the full description for gender. This is the same thing right here. So I start by saying if gender is equal to M, then that's a male. Return the full description male. Otherwise, female. That's the opposite. See? Some other person will say, I'm going to code it like this. If you do this, you have to alter the arrangement. If gender equal to F, then the true part now is what? Female. This part has to be stated first. Right? I really want to draw your attention to this. See that? So this is now the scenario. If I evaluate this, we started off by giving the business entity ID. No logic was done on that. It's returned just the way it is. The job title is also returned just the way it is. We now move to marital status. This is a regional column, the abbreviations. Now this is our attempt to make it descriptive. So we're using the if function. We evaluate when marital status is S, then what did we return? Single. So under this new column called status description, we are seeing single. So whenever this is true, we are telling this function to return single. And if you go through this, the values of this new column runs on a logic. It evaluates this logic. If this logic holds, this is what you're returning. So whenever you see S on this marital status, this is the column we are evaluating. Whenever you see it returning S, then this is what we should return. You see that? Otherwise, it's M. So if it is not single, then it's married. That is a concept of a binary outcome. Right? And that's the same thing we did for the gender. This is the original gender column with the abbreviations M and F. All right, this is now our attempt to make it descriptive. And we state the condition if gender is equal to F. So if we go to the gender column, we'll see F, return female for the new column we are building. This is the new column right here. See? So the goal here is to create a new column. All right. And the values of that new column will be determined by a certain logic. And this is the logic we are building right here. You see? Any questions so far? Let me see if I can take another example. Let me go back to that table. Let's go back to this. So we've done this and this. Salaried flag, this job classification equal to 0 means that this is an hourly employee. Collective one is, yes, we can also do this. I can also build a case statement, an IE function. This is binary. Salaried flag is either 0 or 1. And I can also do it for this one. Let's do it for this one. You see, this is a column that flags if an employee is current, as active, or inactive. If I go back to that employees table, so you see those abbreviations, you can consult the data dictionary to understand. This is a salaried, then current flag. I think all of these employees are current. Right. All of these employees are current. Maybe we can do on the salaried one. Yes, let's do a new build process for the salaried one and make it descriptive. I'm going to copy this. In fact, let me do this from scratch so that we can follow through. So we're going to target those two columns that are not fully descriptive, and we're going to attempt to make them descriptive. And I'm just going to begin by taking this right here and put it right here. That's going to be the start. So our attempt is to take the salaried flag, this one, see if there's any other column that we can use. Pay frequency, yes, we can also use, that's the employee pay history. That's a different table. Okay, anyway, let's go back. Let's do the salaried flag and let's do the current flag. So salaried flag, and then I'm going to stop right here. So let's create a new column which will make this one descriptive. Right? But then I can go back to this salaried flag. This is a description right here, 0. That's somebody who is on an hourly payment. And then 1, that's a salaried employee. I can just focus on those right there. So this is what the business has for those columns right here. So 0 means hourly, that's an hourly employee. And then this right here is a salaried employee. So if the business has defined it in this way, hourly employee, I'm just going to put this like this, add this description to them. And then next we have salary employee. See that? Right. And I'm going to, yes, so this is what we have. Let's use this description to create a new column which will be much more descriptive than just 1 and 0. Not everybody will be able to look at 1 and 0 and understand what's going on. So if you're building a report, you want to decode this. This salary flag has been coded. It has 1 and 0. That's a code. And the meaning of that code is in the data dictionary. Right. So you could be given this requirement to decode this to make it more descriptive. And since there are two options, this is a binary outcome. It's best for the IE function, right? Keep it simple. We use the IE function. See that? So the IE function is suitable for binary outcomes. Yes. So the salaried flag can be 1 or 0. That's binary. So see what I'm going to do right here. I just remember, okay, there's an IE function. I state the function. It's a function, so I open and close the parentheses. Let's go back to the syntax. Once you state the function, what do? Impose a condition. That's the first part of the function. Impose a condition. So what is our condition? We're going to be testing if the salary flag is equal to, you can begin with any of this. You can begin with 0, but make sure you stick to that logic. So I can put salary flag equal to 0. Then what should we return? You have to return hourly employee. That is the true part now in this scenario. So you put a condition, and based on the condition, this is the true part. So our condition is using salary flag equal to 0. And this is the meaning of the code 0. And this now becomes the true part. So I'm going to put a comma, and that's going to be a string. I'm going to put it like this. See that? So you either 0 or 1. That's the situation in this table, you see, on this column. Right. So if I've already defined this, any other person will now be the opposite, which is 1. That's salary, this one. And this is how you transform that. So let me run this so that you can see the new column we've created, and you can see the you see that. So whenever we get 1, it is the negation of is the false part of this condition, which is this. So we get salary. When we get 0, it's what we defined as a condition. So this is the true part based on this condition. This is very important. And this is the false part based also on this condition. See that? I don't know if this is understood. So this is the breakdown for the salaried flag column. Let me just put it right here. Right. So that's how the business captures salaried flag. And we got this definition from the data dictionary. This is the salary flag, and that's how it's described. Let's do one more for the current flag. So I'm going to do the same on current flag. So I'm going to put the situation for current flag right here. And it's just going to be this and this. So the column we are defining right here is current flag. And this is the business scenario. This now fully defines what the 0 and 1 you see on that column. What does it mean from a business perspective? Right. So again, I'm going to do the same. I'm just going to copy this and put the situation right here. We're just going to dismiss every other column except the one we are testing, which is the current flag, this one. So this is what the business is showing us at the moment from the table. But then the meaning of 1, that is an active employee. And then 0 will mean an inactive employee. So it looks like all the 290 employees are active, are not seen as 0. Right. So how can we render this column more descriptive? Yes, since it is 1 or 0, that's binary, we can use the IE function. This is really straightforward. Right. So we can use the IE function. I'm just going to put a comma right here and call the function. Always remember that this function will test the condition. So in this case, the condition we're testing is based on this column, the current flag. So when the current flag is equal to, you can code either 0 or 1. It doesn't really matter, right? But then you have to understand what you're doing. So if I go for 1, if the current flag is 1, then what should we return? That's an one means an active employee. So that's it. One means active. Right. I'm just gonna add this to that thing. One means that's an active employee. Right. And then what is the alternative? You are either active or inactive. So what's the alternative? We don't need to state the condition for the alternative. This I function carries one condition. This is a true part, and then what's the false part is based on, of course, the condition. This is the false part. So the opposite of one will be inactive, which is 0 in this case. Right, and that's how we're gonna build that scenario. I'm just gonna put this extension right here. And that's it, that's the end of that process. So the I function is really simple. You're testing one condition. If this condition holds, what value should be returned? Active employee, that's the meaning of one. Otherwise, what do you get? Inactive employee. So if you execute this, again, you notice that all the 290 employees on this table, they are all active employees. That's it right there. So sometimes you see tables have columns which are coded, right? And usually project owners don't want to see this in the final report. They want to make sure that a user can see the full information. So instead of showing this column, they're going to show this one. See that they'll tell you to do a transformation of that column to make it descriptive. So if it's just one condition to evaluate, use the I function. Your next question will be, what if we are looking through multiple conditions? Yes, that's when we now switch to the case statement. This is very, very important. I want to stop right here and show you something. What if you're asked to look at, let me go back to this. I just want to make a business question out of this process. Let's run this. Do we have any information on salary? Show the salary of the employees on this table. Vacation hours, hire date. Okay, let me just ask this question. If I ask you, what is the total vacation hours for active, no, salaried and non-salaried employees? No, salaried and hourly employees. What is the average, the total vacation hours? Let's look at total vacation hours. This is, let me just go to a new query window and put this. I want to show you how a question can be asked, and there's no direct way to extract that information. You have to, there are no full columns that you're just going to go and pick them up from it. See, this is very important. I want you to see, the basis is this, right? I'm going to take this and put it on a new query window. This is the basis, this is the foundation of the question we're going to be answering. And I want to take this right here, Control C, and I just put it, not this, put it right here. Right. I'm going to dismiss. Yeah, we have this. It's just a follow up. Now, this is the question right here. What is the average? Oh, no, not average. Let's look at total. Yeah, anyway, we can look at the average. Yes, let's look at, since average keeps coming up, let's look at the average. So, what is the average? What is the average vacation hours? What is the average of vacation hours? For hourly and salaried employees? It is for hourly and salaried. And the foundation of this question is more like a comparison. I want to do a comparison analysis. Right, comparison analysis. So you show me the average vacation hours so I can compare. Our hourly employees, do they go more, do they have more vacation hours or compared to the salaried ones? This is a comparison analysis. Right. And I really want to take you back to this table so that you see that based on the way this table is presented to us, we don't have the full information. We need to do some, we need to extract some information so as to get to. So let me run this so you can see. Right, we don't have a column that is just capturing the information we need. See, yes, we're gonna need this one, the vacation hours here. We're gonna need this because you're looking at the average vacation hours. But we have a column that tells us if it's a salaried employee. Oh, this is this one. This is the one that differentiates that. So 1 year will mean hourly, salaried, and then 0 will mean hourly. Now, this is what you can do. I'm going to ignore this part. I can just start by looking at what any other person would do on this. Right. I will isolate the 2 columns we need. And of course, this is going to be an easy question. So I'm going to isolate the 2 columns we need. We need the salaried flag as the first column. And then the second column will be the vacation hours. Vacation hours. So let me just run this so that we can see the 2 columns. Right. In the business side, 0 means hourly, 1 means salary. Right. So now we are looking at what average vacation hours. Right. So we have to transform this into an averaging. Right. And of course, if we transform this into an average, then we also have to make sure that all employees that are salaried, we have to put them in one group, and all that are hourly, we have to put them in another group. Right. So if I run this query, it's going to fail because we've not done that grouping. The average vacation should be computed for each of the 2 groups of the salary of the 2 groups of the employees based on salary. See that? If I remove this, then we're just averaging across the entire value. This is it. This is fine. But then the presence of this means we are doing a breakdown, right? So you have to put this in the group by. I think by now we understand this logic. I have to put this in the group by. So all those hourly employees will be placed in one group, and the salaried ones will be placed in another group. See that this is what you get. But then see how funny this thing looks. Compare it to a scenario where you actually put the meaning of the 0 and the meaning of the 1. Right, so instead of showing this salaried flag, I can go use this logic to, to make it more descriptive. So this is what I'm going to do. I'm going to copy this. Now I want to make this much more descriptive. This is definitely what you first of all do and show it to your manager and say, no, I don't go back to the data dictionary and you see how this is coded. I want to see the hourly employee in the place of 0, and I want to see the salaried employee in the place of 1. Now, this is what you do with the IE function. It's going to be we're targeting this. So I'm going to put the IE function around that concept. I always type this. This is something different. So if this equal to 0, what is the business saying that? What do we get? If that is equal to 0, that's an hourly employee. See, I have to put it right here, and that's going to be a string hourly employee. Otherwise, what do we get? We get a salary. That's the meaning of 1. So it's binary. So once you've defined 1, the opposite will be the other one. And that's the simple scenario when you're dealing with the binary outcome. So this is it. So take note, I need a comma right here. So once I've modified the structure on the grouping, it's just the same. So 0 still means hourly employee, 1 still means salary. So I can keep this grouping structure right here. It's still going to go through. This is what I'm trying to say. I know some other persons will say, no, we can, since we've modified that, we can copy this and maintain that structure in the group by. You have to understand that we've not distorted the concept of 1 and 0. We've instead made it more descriptive. So this version will still work, but your code looks bulky. It's too much stuff going on. So you can still maintain the grouping structure, which is the original column, salary. We are using the I function to just make it more descriptive. We've not distorted the meaning of 0 or the meaning of 1. So keeping the salary group by salary in the grouping structure is the same. You see that it makes your code much more better. You see, compare this version to this version. You see that this is just too busy. You see, but so this is something to pay attention. Once you've not distorted the business meaning of your grouping structure, then there's no need to put that descriptive definition on the group by. You can keep it simple by maintaining the original column. In this column, 0 has the same meaning as in this definition. We're just trying to make it more descriptive, you see. Instead of having 0, we want to get the hourly employee. Instead of having 1, we want to get salary. So you can still keep the group by on that original column. It does not distort the business logic. Like this is very important. See that? So I'm just going to keep that version and we can now execute. So compare this scenario with this one. Right. So you're going to see questions like this, right, showing up. This one is even simple. We did not do some serious deviations from the original construct. Right. I'm going to show you another example where there will be some deviations. You have to really define it, change certain things, and then get the full grouping structure. Right. You know what? I'm going to paste this. I'm going to copy this and share. Right. So all the way to the top. I'm just going to give you some time to look at that. Please, if I'm too fast, can you just make sure you slow me down? So I'm going to pause right here so you can look at this. This is a first part we did just to show you how that breaks down and spreads and make that column more descriptive. Instead of showing this to the end users, this is what you're going to show to them. They will understand this better. Right? Or you can show both versions, this code and this is what it means. Right? And then you see this other analysis we did right here. We're comparing the average vacation for salaried and hourly employees. So this outcome right here, not everyone will be 0. What is the meaning of 0? 1, what's the meaning of 1? You see how a better analysis can be done from this. This is fully descriptive, you see. All right, and I can still maintain that same column name. Right, I can still call that same, maintain the same name. That's the salary flag. See that? Right. And then now this is what the average. That's the average vacation hour. So this version, of course, is much more better. No, everyone understands what they're saying right here. Compared to this one, people want to know what's the meaning of 0, what's the meaning of 1. That's coded, you see. So if you are faced with this kind of situation and you're dealing with the binary outcome, go for the I function. I know the next question is, what if we have multiple things to check? We are dealing with a non-binary situation. That's when we're going to move to the case statement. Right. So I want to pause right here so that you can explore this. I'll take this and add it to the notes. I'm just going to put it below before we get to the case statement. I'm just going to put it right here. So right here. During the lab, I think I'll show you guys a question that is tied to this as well from this website. I think that question was on New York Times, this question right here. I don't know if you have the data set for New York Times. I don't think I've shared that with you guys. Okay, we're going to see that during the lab. I don't think we have New York Times. This is M, there's no N. Yeah, so that question is tied. You're going to use that same concept right here. Let me just run this so that you can see. So we have tablet, laptop, and phone. These are the three ways people view New York Times articles. So New York Times is like, it's a journal, it's an online journal, right? And this device type is simply tracking what device the person is reading the news. Is it laptop, phone, or tablet? So what you're asking this question is to look at, I think what's the key stuff, write a query that calculates the total viewership for laptops and mobile devices, right? If you go to the device type, you see laptop, excellent. But then see the concept mobile devices. What are mobile devices? We have laptop, there are three devices. See, question even starts by acknowledging that there are three devices. There's tablet, laptop, and phone. So they've made a new category, which is what? Mobile devices. They've preserved the laptop one, but then they've made a new group, which is what? The mobile device. Mobile device constitutes of what? Phone and tablet. So you have to build either a case statement or an IE function to put laptop on its own group, and then you combine the views for phone and tablet into what we call mobile views. The question will tell you, right? So assume you're given the table on that by device where the three device types are this, this, and this. You're going to preserve laptop on a separate group, but combine the views for tablet and phone into what we call mobile. So you're looking at two groups instead of three groups as built in the equation. See, they are interested to see laptop on a separate group, but then combine the phone and the tablet one to create what we call mobile views. So you're going to use the IE function, device type equal laptop, then you put that on a laptop. But then when device type is in tablet and phone, that is now the mobile view. You have to create that classification before you can solve this question. This is very important. And I think these guys they use the case statement. All right, that's where we're heading to. See. All right. Anyway, I will come back to that question during the lab session one, so that I can provide you with the data set. All right. So sometimes things are not direct. All right. You have to make sure you extract them, have all the requirement before you can now proceed to do the analytics. All right. Okay. If we are okay with that, let's address the case statement. This is a very important concept in SQL, case statement. Okay, the case statement is right here. It is just an extended version of the IE function. So everything the IE function can do, the case statement can do it. All right. So maybe I can just introduce it by going over the topics we've solved using the IE function. We're going to now use the case statement to solve them. Right. So apply the logic below on the gender column. Let me see if I have There was a lecture material on this moment. I actually have the New York Times that has this that I provided. Yeah. Yeah, I mean, we're gonna come back to that question. Yes, maybe we can do it today. Yeah, we're gonna solve that today. I'm looking for, I did not attach the the explanation of the case statement. Yes, I've forgot to attach that. But anyway, let's just go ahead. I will provide you that explanation. I think this is it right here. No, this is something different. Yeah, I'm going to provide you that explanation later on. Or better still, I will use the I'm going to use this to explain right here. I'm going to come back to this and explain what the case statement is all about. So this is the part we're going to address. It's a very important topic. And where did they place it? They place it under the intermediate SQL. Right, it's something that's easy to understand. Okay, let's get to it. So the case statement evaluates different conditions and return different values as per the conditions. Right. So we solved this question above where we took the gender column and we returned the descriptive version of it. That's using the I function. Let me just go back to what we did above. This is it right here, the gender, and we return the descriptive version of it. See, I want us to solve that same question using the case statement. And this is it right here. So this is the gender column. All right. So every case statement begins with the keyword case. Although we are treating this as a function, technically it is not a function. If it is a function, then you're going to put case and then you put this. See that? But that's not what we're going to do. We call it the statement, the case statement. It is not typically a function, although it's treated under the concept of logical functions. But of course, every function we've seen, they mostly have that parenthesis after the name of the function. So the case is somehow different. We refer to it as the case statement, right? So every case statement begins with the keyword case. And that's a keyword right there. Then what's the next thing? You put the when, it carries a condition. The same kind of condition we place in the IO function, right? But then you put when, still the condition, and then carries the outcome. So when you go to this column and you see M, so when this column reads M, then return male. That's now the fully descriptive version. There is no comma. We go to the second, we put when, and we state the second condition, then return this. And that's why the case statement is powerful, because each line carries a condition and an outcome. If you have 50 conditions and 50 outcomes, you can list them out. You see that in the I function, we're limited to one condition, an outcome for the true and an outcome for the false. See, but within the case statement, you can list several conditions. And please remember, we have just one keyword case, and then each when carries a condition. So whenever you see when, what follows is a condition. And then whenever you see then, what follows is the outcome. If this condition is true, what should we see? You show me male instead of M. If this condition is true, which is what? Gender equal F, show me female. So the then carries the outcome. Please remember this: when carries the condition, then carries the outcome. And then this process is a loop. It keeps running. You have to end it. Keyword end is very important. So I'm ever for this particular scenario, I'm evaluating just two conditions. I end it right here. Without the end, it's a syntax violation. The system thinks that the process continues. You see, so this is very important. You have to end it, and then of course we are building a new column, and that's the name of the new column. So if I put everything we've done and execute, it's the same result you get if we use the IE function. Right? Maybe I just put a comma right here and just state what we will get if we went through the IE function. So if I want to use the IE function, so I'll just put it next to each other. The IE function takes a simple condition. We are evaluating gender. Then you decide gender is what? Either M or F. If you want to begin with M, if gender equal to M, then this is now the condition you're testing. What should you get if this condition is true? M is defined as male. That is now the true part because you're testing on M. So this is what we're going to put. All right. Otherwise, what do we get? You get the opposite, which is binary. We get this female. And that's how the IE function operates. There's no N. N goes only for the case statement. That's all about the IE function. All right. So let's test this. Put it on. See, so this is what we got from the case statement. That's the name of the column. After the N, you put the name of the column. This is the case statement approach. And then this column right here is what we build using the IE function. You see, they all agree. If gender is M, this is the original column. We get male. That's what the case statement evaluated because it fell on this. We return this. So you see, if this condition is true in this particular row, M, what do we get? Male. So it's just for you to remember that the case statement has one keyword case. It has a combination of when and then. Each when carries a condition, then carries the outcome. So it is testing this as per the table. This is what we see in the table. You cannot test on something that's not available in the table. This is very important. Right? Meaning that I cannot test this. See that this is not available in the table. You cannot test this. The table has M or F. That's what the table has. You have to understand what you currently have so that you can build what needs to be shown. You cannot test on this because that's not what the column has. So you test on what is available, what the column recognize is M or F. In this case, we are dedicating this first test on the M. So when you see an M, that's the testing of the condition, then what should you return? The then carries what will be returned. See? And that's the new column carrying that. See? So this and this are the values of the new column you're building. You have to really understand this process. See? So this is side by side what the case statement will do and how the IE function will do it. So you see that anything that the IE function can do, the case statement can do. And you can extend the case statement to multiple conditions. That's where we are heading to. Right. This is another example with the, this is the same thing with the gender. Skip this one. This is an interesting one I want us to take a look at. So I start by exploring this table. I want to see what is a minimum vacation hour and what is a maximum vacation hour. That's how you report the range of a given column. So my vacation hour ranges from 0 to 99. See, that's how you're going to report a range of a column. And then now this business logic, this is what the business will give you. Right. So basically, manager wants to reward employees based on the number of vacation hours they've used. So if an employee has consumed 0 vacation hours, they're going to give you a bonus amount of 1,000. See, if your vacation hour is between 1 and 10, then you qualify for this amount. If the vacation hour is greater than 10, then you have no bonus amount. You see, this is a business logic they've given you, and they want you to implement it in the database in a query. So basically, you investigate let me go back to that. This You're going to evaluate each employee's vacation hour and decide what bonus amount they qualify. You see, this is a this is a logical function. You're evaluating a logic provided to you by the business, and from there you're deciding how much each employee qualifies based on the guideline provided to you by the business. This is very important. Use the following logic to determine bonus eligibility. So, for example, if I stay on this employee right here, they used 99 vacation hours. So, how much should they qualify based on what the business has provided? This person falls in this category. Vacation hour greater than 10. So, they qualify for $0. See, this person, let's go to the next person. This person has used 1 vacation hour. So, based on the business guideline, this person falls in this group 1 and 10. So, this person qualifies for a $500 vacation bonus amount. See, you have to look each case across the 290 employees. How many conditions are we going to evaluate? There's 1, 2, 3 conditions. We cannot use the IE function in this case because it's no longer a binary outcome. We have more than 1 condition we're evaluating. So that's when the case statement comes into, to rescue us. You see, this is very important. This is typical in most businesses. There was a time in the US when COVID hit, a lot of people lose their job and government wanted to give some help. The stimulus package. And that stimulus package was based on evaluating your annual income, and then they decide how much you qualify for that stimulus package. If they had a guideline just similar to this. So some people had no stimulus package because they were considered high earners. Their income was above the targeted range. And some people had a generous amount of money. See? So that is how you can implement that criteria. See? So this will be needed by the HR department so that they can know how much to pay people. You have to evaluate each person case by case. If you had 1 million rows, it will be difficult to do this process manually, but you can code this. See, that's exactly what we're going to be doing right here. I will dismiss this. So I just want to show you this is our target, but I'm going to dismiss it so that we can build it together and you understand how this process works. So I'm going to dismiss this right here. So I want you to understand that the goal is to build a new column called bonus amount. And that column will be built from this one. This is what we have in the table. We have vacation hours. The company is using the vacation hours to determine how much bonus amount you qualify. You see that? So this is the new column you're going to build. This is what the business will use to pay people up. See? So they want you to build it and you have to make sure you code it correctly. Right? So I'm going to dismiss this and go back to the original stuff we have. This is the original stuff. Execute right here. Now we're going to create a new column which will then decide how much this person is going to be paid, how much this is going to be paid, just like that. So please remember, this is a case. This is not something we're going to use the IE function. We have 3 conditions to evaluate with 3 different outcomes. We evaluate this condition, we get this outcome. We evaluate this condition, we get this outcome. We evaluate this condition, we get this outcome. See? So there are 3 conditions to evaluate with 3 different outcomes. And this is a best scenario for what? A case statement. So let me just show you what we're currently dealing with. These are the 3 columns right here. The column we're going to use mainly for this bonus eligibility is the vacation hours. So I will begin this process by calling the case statement. Every case statement starts with the keyword case. Now you have to follow this up with the very first condition. How do you bring in a condition? Always initiate the when. The when is the keyword that is needed for the condition. This is the condition right here, you can clearly see. So you're building the condition just like how you build things in the where clause. So when vacation hour is equal to 0. I just want to do something right here. Let me add an order by. You can see order by vacation hours. Right. Let's do the default, which is ascending. So I'm just going to run this. I'll keep this in front of you so you can see the buckets we're creating. Right. So in the first zone is this one. For those employees whose vacation hour is equal to 0, that's this group right here. How much do they qualify? So our first scenario will target that. So where am I? Right here. So let's call in that logic. So we begin with the case statement. We put when. We are using vacation hour. So the first condition says if your vacation hour is equal to 0, you've not used any vacation hour, we have to pay you for that. What is the bonus amount? Is this? See that? This is very, very important. I'm just going to copy that value. So the when, this is the point I want to make. When carries the condition. Then carries the outcome. And this is going to be a string. So I'm going to paste it right there. This is the bonus amount. And usually I always try to format this by doing it like this, so that you see that this applies across the board. It's not a scenario where every line carries a case. That's a mistake students do. We have one case keyword, and then we now use a when to carry the first condition. First condition as per this is this one right here. And what is the amount you get? This is it. So the then carries the outcome. So for all those whose vacation hour equal to 0, these 3 individuals right here, they qualify for this amount. So in the new column we're going to build, you're going to see this value showing up for this, this, and this. We are done with that first group. You don't put a comma. No, you just go to the next line. So I'm going to delete. I just go to the next line. And then the opening condition for the next line is initiated by the keyword when. It's based on what? Vacation hours between 1 and 10. I'm going to type that vacation hours. This is the key column, vacation hours between. Of course, we recognize this from the where clause between what? 1 and 10. And if you go to the output, all of these people right here, 1 all the way to 10. If I can zoom that area right here, this group will qualify for the next amount. I think that should be half of the original, which is $5,000, $500. You see the group? Remember in the between operator, the endpoints are included, 1 all the way to 10, and 10 is also part of it. This is the group of individuals who will receive that $500 as bonus. So all of these people right here, they will fall in that category. So what does the business recommend? We give these people 500. So this value goes into what? Then that's the outcome. If this condition is true, what should we get? Then this amount, and that's a string. See that? Some people stop right here and they just put the last thing in the else block. The case statement supports an else block, which is a nice way for people who don't want to type too much. If you have 3 conditions, type 2 and then push the last one to the else block. Right? Some people prefer to type everything. So for now, let's dismiss this. Let's type every condition out. The next condition is what? Those with vacation hours greater than 10. See, 10 is already in the previous scenario. So greater than 10, you have to understand it's not greater than or equal to. It should be strictly greater than 10 because 10 will fall in this zone. So the next zone should be this one. I want to type the condition. I initiate when. The condition is on vacation hours. That's a column greater than 10. There's a reason why they should be strictly greater than. You cannot put greater than or equal to. No 2 values should qualify on 2 zones. If somebody qualifies for this, they should get this. Just imagine if the same person qualifies for this. That's what you're doing if you put equality. because 10 will fall in this zone, it qualifies, and then 10 will also fall in this zone. So that's already confusion. So your zone should not overlap, right? So this is strictly greater than 10. So 10 falls in this zone. Anything greater than 10 falls in this zone. This is very, very important. When you're building the case statement, you have to make sure that you don't have overlapping in the outcomes. So what is the business requirement for those with vacation hours greater than 10? $0 amount. So this is it. Where am I? Right here. So there is a then that follows. I think by now you understand that the when carries the condition, the then carries the outcome. See, I'm still getting an error. See, if I stop right here and execute this, you're wasting your time. The system thinks that you have another condition that follows. See, you have to tell the system here that's the end of that process. This is very important. The case statement has to always have the end keyword. After everything is said and done, you have to end the process. See? So the system now knows there are just three conditions to evaluate. The when carries the condition, the then carries the outcome. The case statement looks funny when you start building it, but when you remember these key things, it starts with the keyword case. Each condition is stated on the when clause. There's a condition right here. If this condition is true, what do you get? The then carries the outcome. There is no comma. You just simply move to the next state. You see, that's have this structure in mind. This is very, very important. And that's it right there. So this is the column the HR department will need to pay people's bonus amount. You've already made their work very easy. You've evaluated this and so let's make this interesting. The goal of this is what? The bonus eligibility. So I'm just going to use that as an alias for this new column we've built. So we end the process right here and we put this keyword as. So the goal, we are building a new column and the name of that new column is the bonus eligibility. Let me just put this uppercase. Or just put bonus amount. Keep it simple. Bonus amount. Yes, so that's the new column we've created, and this is it. Yes, so this is what the HR department will use to pay these amounts to the respective. You see, and you can follow the pattern. Always test your stuff. The good thing is that I've put an order by. I'm ordering by vacation hours, so I can easily just test my logic and make sure it's in line with what the business recommended. Don't build a logic without testing it. See. Okay, let's start testing this. It says that if the vacation hour is equal to 0, then they get the full amount. This is a zone right here. Or there are just 3 persons that did not use any vacation, did not consume their vacation hours, you see, and they are eligible for the full amount. That's it. Our logic is capturing what the business recommended. Let's go to the next. The next says all those vacation hours between 1 and 10. So this is the zone right here. 1 all the way to 10 right here. See, 10 also included. That's a between operator. So the endpoints are included. 1 is in that zone, 10 is in that zone, and everything in between. I think we've had this conversation on the between operator. You see? So you see, all of these persons qualify for half the amount, which is 500. See? The moment you are above 10, you go to 0. So 11 all the way to the 99, 0. Yes, and that's how you do the test before you can now share this with your manager and you're confident about what you did. See, and if you notice what I did, I started by exploring the range of the vacation hours. So employees have taken 0 vacation hours all the way to 99. That's the range. Now we can code this logic. See, I want to stop right here for questions. First of all, let me give you time to go over this. All right, and if there are any questions, let's talk about them. Please, I'm going to pause right here. Go ahead and evaluate this. Please focus on this. Just go ahead and evaluate this and then run the query. If there's any line you don't understand, let's talk about that. I really want you to understand this. Case statement is a very powerful concept in SQL. Okay, guys, I'm going to share this later on. This is something that is very important. We can see the different components of the case statement and what they actually do. So in this example, we have the keyword case. That's always the opening keyword for the case statement. And if you look at this outline right here, it says initiates the case statement. This is very important. All you need is just one of these. Right. And the next what follows is a when. And so when you put down the when, guess what? It expects to see a condition. So the when carries a condition, and you build that by choosing the field and the condition. In this example, we're asked to evaluate the vacation hours so as to determine eligibility for the bonus. So the column we're evaluating is vacation hours, and that's why every single one of these conditions carry the vacation hours. So you state the column, the field, another name for field is column, choose the column and the condition. And of course, the different scenarios carry different conditions. This right here, they all have the same field, the same column, right? but they are built to carry different conditions. This is equal to 0, right? Then when does the then come in to state the outcome, which is what the result when the condition is met. So if the condition you place in the when clause, if that condition is met, what should we see? That's what goes into the then. Right? So this condition, if this condition holds, what should we see? This is what we should see in that column. Let me project this column again, this result again. So if this condition is true, vacation hours equal to 0, that's it right there. What should we see? The return, that's the then. You see, all of this carries this amount because that's what we stated. See, if I go in there and maybe alter this into something, just something like that, you see, it's going to change. The return for that particular set is going to change, you see, right here. So this is very important. The then you specify right here is a return the result of this particular condition. Right. So this is something very important to remember. So you have a series of that case, a series of the when, which carries the condition, and the then, which carries the outcome. And this is very important. Once you understand the structure, you can build any case statement. Right. And then this part right here, the else. Let me just talk about that briefly. You're going to see that in the next set, this one right here. So remember, they gave us 3 zones, 3 conditions to evaluate. So what people normally do, they build 2 out explicitly, and they push the last one to the else block. So see what we did. Here we've stated all 3. We did not use any else. Right. In this one, we stated 2 scenarios. And then we push the last one in the else block. This is the else block right here. Now, the danger of using this is if an employee has a missing vacation hour, then it will be classified in the else. So anything that it cannot evaluate, it will push it to the else. Right. So it will evaluate these ones. This is a strict condition. This equal to 0. You cannot miss this. This is also a strict condition between 1 and 10. Any other thing will go into the else block. So if you're dealing with missing values on vacation hours, it will push it to the else block. Right. But then you can also incorporate that. You can define all of these 3, and then before you go to the end, you can now add an else right here. What if somebody has a missing vacation hours? Else null. Just return null. Don't do this or this or this. Just return null. So sometimes a business can give you that information. But then since we're dealing with a company scenario, they understand that every employee has a vacation hour. So you're not going to be seeing misinformation and stuff like that. Right? So this is it. So this is another way to do that same concept we did above. We define, if you have 3 conditions, define the first 2, push the last one to the else block. If you have 10 conditions, define 9 and push the last one to the else block. See? So if you're interested in the else case scenario, this is the default condition. Right? So in this case, if you are not in this zone, you're not in this zone. Of course, you'll be in the zone that is greater than 10, and they qualify for $0 amount. You see? So this right here is the same result as what we get when you define explicitly all the 3 conditions. Right? Hopefully, I hope this is understood. Any question on the else block? And after that, of course, you have to end the process, and then the AS keyword provides the name of the column. End the process, and the AS keyword provides the name of the column. AS is optional. You can still remove it. It's still gonna do the same, right? But then the end is not optional. In the case statement, it must always have an end. This is very, very important. Right, so if I run this without the AS keyword, it's still gonna deliver. If I put the AS keyword, it's still fine. It makes it more explicit right there. Any question on the case statement? Any question on this outline right here? One other mistake I see students do, they want to make sure that every line has a case. That's wrong. Put a case right here, put another case right here. This is wrong. There's only one keyword case, and that initiates the case statement. Once it's initiated, you're good to go. And make sure you terminate it with the end keyword. Any question on this? We're going to see more examples. I just want to make sure that we're good on this. Okay, if there's no question, I have a question right here on the case statement. When the case statement is used, what other statements need to be used? So 1, 2, 3, which is the correct components of the case statement?
I'll go with the last option.
The last one. So technically, there's a confusion between 1 and 3. Yeah, because we can dismiss this one. There's nothing in the loop. Loop is not a component in the case statement. Look at this right here. The loop is not mentioned, right? So I know what is going through your mind is, of course, you've dismissed this one. So the confusion is between this one right here and this one. This and this are both correct, but which one is more the best option? Let's just put it that way. Alex, you're going with it.
Or is it one in that case, because since it says else is kind of like default or something?
Yeah, since you can still build a case statement without else, like what we did in this example. See this one, this example, this is a case statement, is no use of else is needed because we've explicitly defined the 3 conditions and their outcomes right here. You see this, and then the second one, I did another option where I defined the first 2 and then use the else block to capture the alternative. So if you're not in this, then you will be in this. That's what the else is simply saying, right? So if this is a thing, this is kind of a tricky question, but I think from where I got this question, they opted for the first one. So when the case statement is used, what other statements need to be used? So you see that else is optional. It's not technically needed. So what is really needed is the when, then, and then the AS keyword. So you can choose to not use the else. In that case, you will have to define each of the conditions explicitly, all of them. See that? Which still works. This is it. Right. Alternatively, you might want to reduce your typing and just define the first 2 and say, hey, if you're not in these zones that I've defined explicitly, then you'll be in this zone. That's the else. Right there. The secret of this is just more examples, right? So this is what I want us to do. I did provide you with the database for TransUnion. Can you just go and execute that database? Just open and execute it so that we can take one more example on the case statement, which will help us understand this concept better. So yes, let's go to the lecture materials for today. That's week 6, day 1. There is a database script for TransUnion. This one right here. Just go ahead and open that script and let's execute it so we can have access to this. If I execute this, I don't have access to it. So I have to first of all run that script. So open the TransUnion database script, this one. And once you have it open, Just click on execute, and once it's successfully executed, just go ahead and close the script. Please don't run it twice. Just run it the first time, check query executed successfully, shut down the script, and we're done with that script. Now, if you execute this, you should be able now to connect to the TransUnion database script. The TransUnion database is right here. And I will just take you through the database. Further information, you can get it from this PDF document. It's a PDF document right here. TransUnion database project. This right here. So this is all about credit score reporting. I think those in the US and Canada, I don't know about Europe, but I think yeah, they should have a credit. So a credit score is simply a value that runs from 300 to 850. And this just depicts the credit worthiness of a customer. If you want to borrow money from a bank, you want to buy a car, you want to buy a house, they're going to use this score to see how trustworthy you are when it comes to, paying back your debt, basically. Right. And usually based on this, the bank can give you a good deal if you have a good credit score. Right. For example, if you look at this scheme right here, if your credit score is in this range 800 to 850, then you have an excellent credit score. And then this is how the bank will treat you. You're going to get the lowest possible interest rates and best terms. If you want to buy a house, right, you want to borrow money from the bank and buy a house, your credit score is in this range, you have an excellent credit score, they're going to give you the lowest possible interest rate. Right. They trust you, they know you're going to pay back the money. Just imagine if you're in this zone, very bad credit score, 300 to 599. Right? Only secure loans are given for people in this group. They don't really trust you. They're gonna give you a secured loan, and maybe your interest rate is going to be higher compared to somebody in this group. So that's all about the concept of credit score, just to give you an right. Right. So this table we're dealing with in the TransUnion database has this information, right? So we have a customers table, which is this, and the most important column I want us to focus on this is the credit score. So we're going to be using this credit score to classify the rating of this customer. So what does a business say if you have a credit score of 301? Let's go back to that scheme. A credit score of 301, how will you classify that? 301 falls in this. This is a very bad credit score. So that's what we want to do. And look at how many conditions we have to evaluate. 1, 2, 3, 4, 5, 6. Guess what? It will be tricky if you wanted to solve this question using the I function. The I function is good for when you're evaluating a single condition binary outcome. But when you have to go through several conditions and different outcomes, please don't just stress yourself. Just go with this case statement. Right. So you're gonna need this PDF document right here. No, not this. This was the one I just opened, the one on credit score stuff. This one right here. So this question right here, I'm gonna skip. This is a project we're gonna work on, but I'm gonna skip the first part. I'm gonna skip this. We've already done this one. Open the TransUnion database, execute. Rest we've done the first two. The third one is an extraction. We're gonna come to that function later on. Now, so we're gonna go to the question 4. Use the classification scheme below, which is this scheme right here. It's a classification scheme, right? To generate a new column called rating. So I want you to focus on how this question is built so that if you have any doubts, we can address it before we target the question. Now, so we're going to generate a new column called rating. This rating is these values, these descriptions you see right here. Excellent, very good, good, fair, poor, very bad. That's the values that the new column rating will hold. Right. Now, this new column will have values. This is what I just said. Excellent, very good, good, fair, poor, and very bad, depending on the credit score range. So depending on the range of the customer's credit score, you're going to classify that. So for example, this person right here, or maybe let's just look at this person right here, has a credit score of 735. 735. You have to go to this scheme and see where does a credit score of 735 falls. It falls in this zone. So if I was to build this in a case statement, I'm going to put case when credit score between 700 and 749, then good. See that? You can start from any direction. You can start from this all the way to this, or you can start from this all the way to this. Right? So you have to capture each of these scenarios. Right? This is very, very important. I think I have the this is it right here. But like we did, I will do this on a different. I want to repeat this fresh so that we can understand it. Right? And what are the columns that we asked to return? We are solving this question for. Anyway, the columns are not given. You know what? Let's just go and return the customer ID, the company name, or the customer name, and the credit score. We're just gonna keep it simple. We'll start with 3 columns, and then we're gonna target the ratings column, right? So the ratings column is a conditional column we're gonna build. The values are not predefined. We have to explore certain conditions to know the value for that particular column, right? So to keep it simple, we're gonna be returning the customer ID. Show me the customer ID. Show me the customer name. Customer name. Tell me their credit score, right? And now let's build a new column which will now report the rating based on the credit score of any customer. Can you tell me if it's excellent, if it's a good credit score, bad, very bad, poor? See, this is a job for the case statement, right? Now, see how we're going to initiate this process. Let me go back. I don't know why I shut down that stuff. Right here. So initiate the case statement using what? The case keyword. I'm going to follow that so that we can understand that concept better. First thing is, this is me declaring to the database engine I will be using the case statement, and that's the initiation of the case statement process right there. I usually like to take this on the next line and indent a little bit so I can see my flow nicely. Right, now I'm ready for the next one, the when. Whenever you put the keyword when, you're stating the condition, and the condition is built on a certain column, a certain field. The key column we are using in this analysis is the credit score. We are evaluating the credit score of each customer, and we are deciding the rating, good, excellent, bad, and stuff like that. So the column of interest is credit score. I'm just going to copy this and put it right here. Now you may ask me, what direction are we going to begin? What's the first condition? It depends on you. If you want to begin from this end, fine. If you want to begin from this end, fine. Let's begin from this end. Let me see what we have in the lecture material. Where did we begin? We began at the poor side. Okay. So in this case, I'm going to flip it around. Let's begin on the good side. Let's begin from this other side. So in the one you currently have, we started from this. So I'm going to switch. Let's start from this. So you can start from any direction, but make sure you go over the conditions as stated. So I'm going to start on the excellent side. What is the limit for the range of the credit score for the excellent? It goes from 800 to 850. So all customers whose credit score is in this range, 800 to 850, how do you capture that? So I have to put the keyword when, I'm preparing myself for a condition when credit score 800 to 850 is a range. So my choice of operator will be the between. So I'm going to put 800 and 850. 850. This is very important. This condition has been captured. It's in this document right here. 800 to 850. This is a range. I'm using the between operator to capture that. And it's inclusive. Now, if this happens, what should we get? Excellent. So that's the return. And if we go back to this, the then carries the result when the condition is met. So for employees, for customers whose credit score is in this range, what will be their rating? Then this is the result. We're going to classify them as having an excellent credit score. I really want to use this so that we'll build this together and see how the keywords are coming in. Case was the keyword for the initiation of the case statement. Case statement has only one case keyword. You cannot initiate a case statement multiple times within the same framework. You see, right? When you put the when, you're stating a condition. If that condition is met, what should we see in return? This, and we are not making this up. It's what the business has given us. See, we are done with this zone. We now move to the next zone, 750 to 799. Right? Please, you don't put a comma. Some of you will be tempted to put a comma to go to the next line. You're going to have an error and you will learn from it. So it's a gradual process, right? So let's go to the next one. When credit score, the fact that I've put when, I'm targeting the next condition. The next condition is credit score should be between. Now, what do we have? See, 750 to 799. 750, 750, and 799. If this is true, what should we see in the return? The rating will have which value? It will have very good as the value. So if your credit score falls in that range, then we're going to classify that as a very good credit score. See, go to the next. Right. Once you understand this workflow, you're good. Right. So where are we at the moment? We've defined this. We are now on this. This goes from 700 to 749. 700 to 749. 700 and 749. What should we get? This is a good credit score. Good. See, that's what we're gonna get right here. I'm already now tempted to start copying and pasting things, of which I'm. Anyway, let me just type everything out so you can see. Right. So far we've defined three. Let's go back. Define 1, 2, 3. Let's get to the fair zone. 650 to 699. 650 to 699. So 650 and 699, what does the business recommend? 650 to 699, fair. So we're going to be returning fair for every customer whose credit score falls in that range. Right, let's keep going to the next. We are now in the poor zone, 600 to 649. 600 to 649. So what does the business recommend? If your credit score is in this range, 600 to 649, your credit rating is poor. That's a poor credit rating. I'm just going to put it right here, poor. right? So you're not making things up. You're following the business requirement. What does the business say? And you're just simply coding it, right? And at this point, we are now going to the last one. If you want to use the else operator, the else keyword, that's fine. See, so once you've defined everything and you're just left with one, you can push this to the else. Right? If you want to use the else, this is what you do. At this point, you use this. So the else is if you have n conditions, do n minus one and push the last one to the else block. So how many conditions we have? 1, 2, 3, 4, 5, 6. We've explicitly defined 1, 2, 3, 4, 5, and we are pushing the last one to the else block. And you're not stating the condition for this one, you're just going with the outcome. That's the meaning of else. In else, you don't state the condition, you just push the outcome, right? So else, what do we get? If you're not in this, 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 then you're in this. Very bad. We don't need to state the condition, it's obvious. So very bad comes in right there. So we just skip the condition and just state the outcome. This is very bad. Right? There's nothing to debate about that. You see? And you see, I have an error right here. Error indicator. If I execute this, I get an error. Can somebody explain why I get this error?
You forgot to use the n to use the n.
Excellent. See, we have to use the N operator to, conclude this combination of conditions and outcome. Because even though the system thinks that another one is going to come, you might think that the system understand that the else is there, but you have to make sure you end the process. You can put the N in any side on the same line or maybe the next line. I like doing this. You see, this is for readability. You can type all of this in one single line, right? But for the purpose of readability, I like doing this outline. See, and now I can, sorry, not this. I can now use this. What was the target of this question? The target was to create a new column called rating. If you go back to the question now, we're going to be generating a new column called rating, and this new column will have these different values you see right here. Right, so the key thing I'm tracking is this. So we're creating a rating column, a new column called rating. So when I end the process, I'm going to tell the system here, this new column we're creating, the name is this. And if I execute this, this is what we now get. Please remember to fact check, just do some random checks. For example, I see this person, Victoria, they have a credit score of 700. Let me see if my logic correctly classified this individual. So you go to the original stuff, 700 as a credit score. In the far right here, see 700. You see the classification says good, and my logic says good as well. So this is what it means by doing spot checks, some random checks. I don't build a logic and just push it out for people to start using it without you testing it. Right. This one says 799. Yes, let's check that. If you have a credit score of 799, the business recommended was 799. Yes, this is 799. Very good. Let's see what we get for that individual. Very good. See? And again, just some spot checks. This one's, let's check this. Rita, credit score 620. Let's check what the business is. Credit score of 620. 620 is in this range, right? So what do we get? We get, it recommends poor. What do we get right here? Poor as well. Right. So always do these spot checks. This is very, very important. Right. So any question on this? I'm going to pause for a while. Let's go over this, and if there are any questions, we can address it. If you do not want to use the else, then you can go ahead and state that fully. Now, let me just dismiss this. You have to state that fully. See, when credit score between, let me see, the credit score between 300 and 599. Right, so if you do not want to use the else block, you can define that fully 305.99. Then this is the outcome you're getting based on the business. A credit score in the range of 300 to 599. That's very bad. I just have to put right here, very bad. Right, and this is it. So right here. Okay, I think we deserve a break. Let's take a break. We're gonna take a 15 minutes break. After the break, we're gonna continue. Let me see what we have next. Yes, this will take us to the New York Times example. I think yes, we can just do that. Yeah, let's take a break, and after the break, we're gonna do the New York Times example. That's an interview question, right? Okay, let's take a break. Let's go for a 15 minutes break. Back, let's go for a 20 minutes break. Take a 20 minutes break. Okay, guys, are we back? Okay, I want us to see what the case statement is, how the case statement is covered in this documentation right here. Oh, I don't think I have this database. Okay, I will provide you with this database. I'm going to create them. Yeah, it's not a little. Yeah, I'm going to create this database and provide them for you to use them so that you can understand this right here. Yeah, but we can just go over them. So the case statement in SQL allows you to shape, transform, and manipulate data based on specified conditions. It is a powerful tool that lets you customize query results, create new categories, and apply conditional logic. You understand why we are treating this under the topic of logical functions. So it's going to build conditional logic. It's going to test different conditions and return an outcome. So this is an example of a syntax. Always remember is one case, the when carries the condition, the then carries the result or the outcome. And this is just for one scenario. You keep doing that for every other scenario until you exhaust everything. And you can make use of an else. So this says that if no condition matches, return the result in the else clause. See? And always remember to end the process. And if you're putting that on the select clause, it means you want to generate a new column. This gives the name of the new column. So give your new column an alias right here. You see? So I'll encourage everyone to also read this. Let me just think I should add this in the lecture material so that I can point to that others can benefit. So where did we start looking at the case statement? Right here. So I'm just going to add this reference. And I also provide you with the database that is being used in that demonstration. So you can try it out yourself. So let's take a look at this simple table right here. We have the Marvel Adventures table, we have the actor, character, superhero alias, the platform followers, post engagement. And let's see this example right here. So we're using the case statement to determine the popularity category of each Marvel character based on their number of followers. So the column we're going to use in the conditions will be the followers column. All right. So we want to classify them. Always they're going to give you the logic. All right. So based on the number of followers, popular if they have this or more followers. And if you look at carefully, we are testing a single condition. Right. So you can also use an I function for this. So basically the popularity category we are building has the value popular if the followers is more than this. Otherwise, we did not specify. Right. So it's returning a null. There's just two possibilities, either this or this. This is a very simple case of that. I'm going to provide you with examples that this database so that you can test it. And so I'm going to build this database and send the script you can execute and use. This one is much better than this one. This one is much better. So handling multiple conditions. This is the power of the case statement. The ability to go through multiple conditions like what they did in this example. We tested the different credit scores and we provided the outcome. See, this is the power of the case statement. Right. So the business will always give you the logic and you just have to implement it. Right. So look at this one, the one categorized Marvel categories, Marvel actors based on their social media engagement rates. Once you study the table and study the logic, you can always start building that. So high engagement, they actually define the meaning of high engagement. Engagement rate greater than or equal to it. Let's go back to, is it still based on this? Or is the engagement rate character? This is based on a column called engagement rate right here. Right. So we're using this column, right, to classify the Marvel actors as high engagement, moderate engagement, low engagement. And the definitions are provided. You just have to code them. So again, this is the opening of that case statement. Again, single keyword case right there. So when the engagement rate is greater than or equal to 8, this is what the business defines. It's right here. Engagement rate greater than or equal to 8. What should you return? That's the definition for a high engagement. This is it. So you test this. When it's greater than or equal to 8, you return this. What is the definition for moderate engagement? Engagement rate between this and this, inclusive. So they give you the green light to use the between operator. See? So engagement rate between this and this, moderate engagement. So the business will always provide. At this point, you can just stop right here and push this to the else block. Otherwise, you can go ahead and still define it. For a low engagement, the engagement rate is less than 6.0. That's it right there. This is the three definitions that have been provided. The when carries the condition, the then carries the outcome. And you define everything, you end that process with the end keyword right here. And you state the alias for the column. This is the engagement category. It's a new column we're building. The original table has character, superhero. No, not this one. This is the original table. This is the column we're using to build a new column called engagement category. And this is it right here. Right. So this query generates this result you see right here. Right. So you can also use the else in the case statement. Again, the logic is provided. These are the logic right here. And you just code it. How many logics are provided? 3, 1, 2, 3. What did we do? They define 2, push the last one to the else block. Less popular. This is the less popular one. See, they did not put the condition, just put the. I will provide you with the table so that you can practice. This is really interesting. It's a good it's a good thing to practice on this. And if you go to this link, just click on this. You can actually practice this. This gives you the Marvel Avengers. It's limited to 5 rows. Let me dismiss that 5 rows and print out everything. Looks like it's a huge table. Yes, a huge database. See, it's a huge table. Right. Yeah, you can practice this question right here. Right. You can do that together. So this is based on what average likes. Categorize superheroes based on their average likes. What column are you going to be using? This is just trying average likes, this column right here. So how do we define superheroes with super likes? Superheroes with an average likes count greater than or equal to this. I will provide you a database for this so that you can test this on the management studio. And this is the process right here. Right, so you're showing the actor, the character, the platform, the average likes, and in case when average likes greater than this, then that's superhero. That's the definition right here. Super likes for characters with an average of this or more, so greater than or equal to. So if this condition is true, then that's the definition of super likes. Right, we go to the next one, good likes. See, average between this and this, inclusive, that's a green light for the between operator. See, yeah, I will provide you with these other sets so you can practice them. Right, but for now, you can just build them right here and run the code. Okay, I think, let me see if I have a sample for the assignment. The project I wanted us to work on. We're going to do that during the lab session. Yes, I think before the lab session, I'll provide you with this so we can use this also in the lab session. Let me see what I have for 5. Yes, there's going to be a case statement for lab 5, for lab 6. I want us to do one of it and then we can just continue to the next topic. This is a very important topic. So this is what we're going to do in the lab. Okay, anyway, it's loading a new window. Let me just be patient on that. So the things we're going to do, I will provide you this Marvel Avengers table with all these records. Yes, that's one. And we're going to practice all of these exercises. And then the next part, this is an assignment, a project that you all are going to work on. So you're going to see this in the lab. I'm just going to copy this and we can address it. I'm just going to put it right here. Let's solve one of these questions together. Then we're going to solve the rest during the lab session. Right. I think we did this part in one of the questions in the last lab. Right. We are familiar with these two tables to join the employee and the person table. Right. So I'm going to begin by doing that join. Right, and then we're just going to go through these questions together. Then this thing has to end right here. Right. This question is coming from the bigger AdventureWorks database. So AdventureWorks 2022. And we have two tables mentioned right here. I'm just going to copy both. And we're going to explore. Then we start solving those questions. Right. And then every other question, we're going to address it during the lab session. I want to make sure that we have the right tables. So there's the first one. We explore this table. Then there's the second one. So we're going to use this and these tables for this question, right? The first thing we're going to do is combine them, join the two tables together. Let's explore them. I think last time our exploration, we saw the mutual column was business entity ID, these two, right? So I'm just going to begin the join process, and then we're going to combine those two using the business entity ID column. So this is going to be E. We're going to give this an alias E for employee. I will then go ahead and bring the person table. I think from previous knowledge, we know that the employee table does not hold any names. For names, you have to consult the person table. That's why we have to join the person table to get those names. See? Right. And then next is I'm going to bring in the person table. And then this is where we're going to do the join. The on clause employee, we're going to use the business entity ID from the employee. And on the person side, we're using business entity ID as well. This brings the two tables together. We are now ready for the first question. I'm just going to preserve this join if I need to go back to it. So now I'm set to do the first part as part A. What is part A all about? Return the following information about employees. Get ID, first and last name, hire date, employee, years employed, and that will be a calculation we're going to perform. So ID, that is going to be the business entity ID, our business entity ID. I have to reference this, and let's just alias this as ID. It's ID. Right. Let's put the first and last name as stated. We can choose to combine them, but I'm just going to put them separate. In the last lab, we did combine the first and last name. All right, this is first and last name. Let's get the hire date. First and last name. Let's pull up the hire date right here. So far, we've made progress. And now let's get the years employed. And this is a new column we're going to build, which is simply the number of years in the company from hire date to current date of this. So let's consider this to be the current date. See, it's stated. So I will now have to bring in the date function. That's a function that is used to calculate the duration or the time interval between two dates. And since we are told to calculate this in years, this is going to be year. And it begins from when the employee was hired. That's a hire date, all the way to the date that is specified right here. It says December 31st, 2013. So I'm going to put this right here. But you have to remember, we have to transform this into a format that is, the same as what the hire date is capturing. It has year, month, and day in that format. See that? So your next big responsibility will be to transform this December 31st into something like this. The year should be 2013. We're looking at December. We're looking at December 31st. So right here, 31st. All right, so the date interval from the higher date to this date will now be the duration. That's the number of years in the company, and we want that column to be called years employed. All right, so this generates that new column, and that new column has no name. We're just simply going to put this as the years employed. So this is all about that part A for that question. We have the ID, we have the first name, last name, hire date, and the years employed. And this is it. I think we're good on this. This is just making use of one function, which we've studied already, the date function. It tracks the number of years from a given start date to a given end date. Right, so that quantity you see in that last column is years. If you want to compute this duration in months, you just change this to month. And see, this is just a revision. Right. You could also, let me go back to year. That's what was asked. So that's all about the part A. All right. What do we need in B? Add a new column called years employed grouping using the following logic. So if you've been employed in the company for less than 1 year, that indication should be there. Employed 1 to 3 years, employed 4 to 6 years, employed over 6 years. see the logic, add a new column called years employed grouping. It's a new column we're going to add to this group, to this list right here. So I'm going to preserve this and just copy it and take it to B. Let's change this to B. We are going to be adding a new column, right? This should not cause any confusion. We are simply going to add another column right here, and that column will be the years employed grouping, right? And they've given us the structure. So for example, if I show this person right here, this person has been in the company for 4 years. 4 is in this is what we should get. This is the value we're going to get under this new column called years employed grouping. So years employed grouping is a column we're going to create. What do columns hold? Columns hold values. They've given us the logic to fetch the values for this given column. And this is the logic right here. And we're going to be using an existing column, which will be this. So if the years in the company is 4, based on the new column we want to create, this is the value we're going to get, because that 4 falls in this range, you see. And so for this person, we're going to show the label employed 4 to 6 years. For this person, it's same, fall in that. Let's say for this person right here, employed over 6 years, that's what you're going to get. So this is a job for the case statement. You look at the different conditions we have to go through. See, so this one is very special because the condition and the outcome are in the same stuff. This tells you the outcome, and then you can know the condition by reading the outcome. So that's what we're going to do. I'm just going to copy this. So this is the logic right here. I'm just going to put it next to this so that it can help me to follow it through. Right. So, and then the column we're going to build is this the name right here. So these are some of the examples we're going to be going through during the lab session. Right. And guess what? I'm just going to put that name right here. That's a column name we're targeting. And then these are the values the column will host. See? So I'm just going to put a comma right here. After this column, this is the new column we're going to get. And take note, how we've already done this calculation. This is what the duration in the company. So this is a column we're going to use to build at the case statement. Right. So I can now initiate my case statement like this. Case, right, when. So case when what? When this, which is what? The number of years in the company. When this is what? Less than 1 year. So I'm going to put, this is the interpretation, less than 1. This calculation is already in years. So when this is less than 1, the business says that this person should be referred to as employed less than 1 year. Control C, I'm going to put it right here. So this is the then part. This is really, really very important. See, I know I'm beginning to type in a lot of things, but then you have to focus on the context. This is what is computing the duration in years in the company. So when this calculation right here is less than 1, then this is the label, the one that employee to have in the new column we are building, employed less than 1 year. This is it, employed less than 1 year. When you're done with that, you go to the next. Right. The next one says employed between 1 and 3 years. And you know how, so that's why I said this carries the output and the condition, but I really need, the condition, how you're going to code it. And then of course you just copy and put that output. So the next one is when this calculation right here, paste that, this is how you're going to interpret this. This is between, when this calculation is between 1 and 3, then what should we get in return? We are getting this employed 1 to 3 years. So I'm going to put it right here, employed 1 to 3 years. And you have to keep doing that for every other scenario. So we've done this two. We're now on this. This is what 4 to 6. I'm just going to copy this and adjust it. Just copy this and then just adjust it. Once you've already typed something, has the same structure, just copy paste and adjust. I'm just adjusting the endpoint. This one goes now 4 to 6. So between this is now going to be 4, 6. What should this return? If you spend that number of years in the company, this will be the level employed 4 to 6 years. Then 4 to 6 years. Right. If you're a data analyst and you don't know how to work effectively with the case statement, you're missing something very strategic. Right. This is very, very important. The case statement is very powerful. Businesses use this a lot. They're going to give you business logic and they want you to code them and implement them. Just don't stress yourself with a case statement. Right. And then the last one, at this point, I've done 1, 2, 3, 1, 2, 3. I can stop and push this to the else block, or I can go ahead and define it whichever way you want to flow. That's up to you. So I want you to know the different possibilities. We have 4 to go. We've defined 3. Yes, you can stop right here and push this to the else block. In the else block, you don't need to define the condition. You're focusing only on the outcome. Else this, right? And you make sure you end the process. Right, always remember, end the process. If not, you're going to get an error. So the goal was to create a new column which will give full description on the duration of each employee in the business. You see, this is 4. Yes, this is the explanation. Employed 4 to 6 years. This is 5, still the same, 4 to 6 years. See, and then this column has no name, but we remember the name was told. We told the name. We have just copied and put it right here. And the end has that. So this is us providing the name of, right? So some companies have what we call paternity leave. If your wife gives birth or you can qualify for a certain number of months of no work. That's a paternity leave. See, so in some companies, if you have been hired between 1 and 0 to 4 years, for example, qualify for 8 weeks, 8 weeks of paternity leave. If you've been hired between 4, 5, and maybe 9 years, you qualify for maybe 13 weeks. So they keep adding as you're spending more time with the company. All of those business scenarios, these are real company stuff. The HR department uses this on a daily basis. Right? And sometimes when you work with the same company for maybe 1 or 2 years consistently, they give you a 2% salary increase. Companies have different benefit structure they put in place. How do you implement this? The case statement. You cannot run away from this. Not just that, but a bunch of other things. Analytics in business is really not going to be possible without a solid understanding of the case statement. So this is very, very powerful, what I'm showing right here. You have to create time and understand this, right? The logic will always be given to you. All you need to do is just sit back and implement it. Right. So we've successfully added a new column which just does that description based on the duration we calculated. Any question on this? So we're going to see more of this during the lab session. Any question? You know what? Let me just give you this. I'll give you a couple of minutes to go over. The first part is this. This is just calculating that duration. I think you're familiar with this. And then I'll give you the second part, which is now the logic on adding a new column based on the duration we've calculated. This one right here. Right. I'm going to pause and give you a couple of minutes to explore those. And if there's any line you don't understand, let's address it. Okay, so we're going to continue with another set of functions. Let me go back to this. So talked about this. Tomorrow we're going to talk about window functions. I want us to go over this list of functions right here. And this falls under what we call data extraction functions. I will begin this by going back to the TransUnion database, right? So these are the list of functions I want us to cover. I did not prepare the lecture for this, but yes, I just want you to understand this is what we have with data extraction functions. I want us to begin looking at what we call the left function. I will use a couple of online resources to just make you understand this. So this is a left function. The left function is all about extraction. And let me show you a scenario. So we're gonna be using the TransUnion database. But let me begin by explaining what this does. So in the left function, let me give you a string, for example, this. Right, I give you a string. This string is Dallas. It's a city. It's found in the state of Texas. Right. So I give you the city and the state, two together. Now, if I ask you, just go to this and extract only the city. So I want you to extract just this. Take note, we are looking at what data extraction functions. So go to the string Dallas, Texas and extract only the city, which is just this one. So this is what called the left function. It goes to the left-hand side of this string and begins extraction. Now, where does it stop? That's the question. So in the len function, there are two important things you have to declare: the string to extract and the number of characters. See, so you have to tell the system how many characters to extract. This already tells the system you're going to the left-hand side. Yes, we're on the left-hand side right here. You start extracting. Where do we stop? Number of characters. If I specify the number of characters should be 1, 2, 3, 4, 5, 6. The left function stops right there at position 6 and returns everything that's extracted up until that moment. See? So there are two critical things you have to tell the left function: the string you're working on and the number of characters to extract. See? So next, if I now put the left function like this, and I go in and specify the string, I'm just going to put the word string. You understand that, right? Or let me just put expression, right? And then second, very important, the number of characters, to extract. This is a number of characters, right? And with this, we are now ready to start working on this. I'm going to state this following what the left function is expected to do. So I'm going to call my select, call the left function. What do you have to pass into the left function when you call it? First thing is the expression to work on. In case I want it to work on this expression, paste. What's the second thing? The number of characters to extract. Put a comma. If I put 5, it will go to this string called Dallas, Texas. This is it. It will go to the left-hand side. Why left-hand side? Because we have the left function. If you're using the right function, it will go to the right-hand side and start the extraction. See, this is very important. So I'm already telling you there's another function called write, which does the extraction from the right-hand side. You see? So I'm on the left side, and this is the left side of the string. I go 1, 2, 3, 4, 5. If I do 5, I stop right here. I will get this portion. If I execute, that's what I get, you see. But that doesn't give me the full, so I made a mistake on that. I was supposed to push this to 6 characters. So if I declare 6 characters to be extracted, I get dollars, and I can now declare that, hey, these dollars have gotten, that's the city. I can now push this into a city column. This is what we call data extraction functions. See that this is very important. So the expression you're working on, the number of characters to be extracted, these are just 2 simple requirements with the left function. Right, this is very, very important. And before getting into this left function and right function stuff, we did talk about the len function last time. I'm just going to review this. I talked about this, but there is a len function which just captures a number of characters in a given string. Right. So if I transform this into, let's first of all talk about the len function. Right, this one right here, len function, the number of characters in a given string, number of characters in a given expression. Right, this is very important, number of characters, so that we start understanding this from the basic one, number of characters. So this returns the number of characters in a given string. I have this string called Dallas, Texas. I want to find out how many characters are in string, the combined one. Let's begin with them separately. Let's begin with the city. How many characters are in that? How many characters are in this? How many characters are in this? Right, you can find that easy by using the len function. Right, number of characters, just apply the len function. It's just one parameter or one expression to pass, and it will investigate the length. Len is what? The number of characters. 1, 2, 3, 4, 5, 6. This is going to give you the number 6. That's the number of characters in the string dollars. What about Texas? How many characters do we have in the string Texas? This just called your len function, and then you specify the expression. If you're dealing with a table, you just pass the name of the column, and this is what you get. There are 5 characters in the string Texas. 1, 2, 3, 4, 5. If I go ahead and put a space right at the front, it will calculate this, it will count the space also. It's a revision. Right. If the space is, it counts 1, 2, 3, 4, 5, 6, and it returns 6. But then if you put that space, this is what we call a leading space, and this right here is a trailing or a lagging space. It doesn't count that. It's still gonna stay 5. You see, it starts counting 1, 2, 3, 4, 5. It stops right there. The space on this side is not counted. This is just a revision. Right? So that's the len function for this string right here, the full dollar space Texas. It's going to be 1, 2, 3, 4, 5, 6. This is counted 7. This is counted 8, 9, 10, 11, 12, 13. You see? So the len function can do that simple thing for you. You don't need to be counting. All right. And this is it. So that is the len function, right? If we are satisfied with the len function, we can now go back to what we're discussing on the left function. So it's just an extraction. Go to the left-hand side of a string and start extracting a specified number of characters from the left-hand side. It's a left function. This is very important. So if I put Dallas, Texas, I will be extracting from this, from the left-hand side of the string, and all the way 6. That's what I get. I get the full picture, Dallas. This is very important. I'll stop right here, and let me just demonstrate an example from a table. Let's go to TransUnion database. Let's count the number of characters in each customer's name. Select down from, so that we see an example from a database perspective, not just arbitrary, right? Customers, let's run this. Now, connect to the database first, then run that. Yeah. So this is a customer name. Count the number of characters in each customer's name. So show me the customer ID, show me customer name, and then count the number of characters in each customer's name. Right. For the count, it's just going to be the length function. Since you're dealing with a table, you must be passing a column into this customer name. And the first thing you notice is that customer first and last name are fused together. You might have a requirement to separate them into first and last names. That's when the left and the right functions come in handy. So in this question right here, we are counting the number of characters in each person's count the number of characters in each customer's name. See that? Right. So this ones we're just using arbitrary stuff, no table involved. But then this is a good way to begin this process. Just think of some word and just use the count function on it so that you can actually see the count of yourself. 1, 2, 3, 4, 5, 6. And then when you run that, you see that's the best way to appreciate, to test the logic of a function. And now you can transfer that knowledge to a table, right? Now, of course, every customer has different number of characters in their name, so the counting process will be different. See, this person right here has 12 characters in their name. You can go ahead and test that and count it yourself and see the spaces, everything is considered as a character. You count that. See, this is very important. You see variations in the number of characters in each person's name. You see that? All right, this is very important. This is a nice way to test that function. And when you see how it works, you don't need to memorize this. Some of them from the name, you can just explain what they're doing. All right, this counts the number of characters in a given expression, counts the number of characters in a given expression. All right, and you just practice it first with some array. You can put your name, count the number of characters in your name, test it out and see, and then transform it now to a column, connect to database, test it out on a given column. Let's count the number of characters in each customer's name. Just run that and you see it, and you can count it actually, visit each and count and compare with these values. See, that's all about the length function. Now, how do you use it in problem solving? That's another thing. We're going to see how we're going to use that subsequently. Right. The left function, let's go back to the left function. We've demonstrated it arbitrary. Right. So these are the two parameters for the left function, the expression you're working on and the number of characters you want to return. And once it goes to the left-hand side, because the function says left, it goes to the left-hand side of the string, starts the counting. Once it arrives at the limit, it stops right there and extracts everything it has extracted all up to that moment. Right. Now let's see how we can use this in a table. Let's go back to this exercise right here. And let's extract first name from customer name. This is how an example will look like. Extract the first name from the customer name. Right. And if I just go back right here, we are still sticking to that customer ID, customer name. We don't need this part. I'm going to remove. I want you to see that on the customer name carries first and last name. In this question, we are interested only in the first name. Extract the first name from the customer name. So we want to see Maria, we want to see Anna, Antonio, Thomas, Christina, Anna, just like that. Right. But then now you remember, oh, first name is actually on the left-hand side. So let's attempt using the left function. Since our first name is on the left-hand side, left function will be easy to do that extraction. What's the expression in this case is a column right here. And then the part which is going to really make you very confused is what number to put right here. What static number can we put right here which will do the job for every single person? It's not possible. Here we're dealing with one string. We could go in there and test 1, 2, 3, 4, 5, 6. For us to extract the city, that's Dallas, we need 6. But then we are dealing with a column. Column has different values in it. All right. So there's no number you're going to put right here which will magically do the job for everyone. If I put 1, 2, 3, 4, 5, that's I'm targeting Maria. And then any other person that happens to have 5 characters in their first name is going to do the job for them. This is a hard-coded value static, right? You have to understand from this that every person name has different number of characters. So there's no magical number you're going to put right here which will do the job for everyone. This is a very important limitation you should first of all realize. I set 5 because I targeted Maria. See, it nicely extracted Maria. It failed for Anna. You see, Anna, it took 3 space plus 1, that's 5, plus T. The 3 in the first letters, 3 first name letters, a space 4 T 5. You see, Antonio, it just messed up that Antonio. Maybe this is the alias name for Antonio. It's in the Thomas, it missed out on the S. So the moment you hit your limit, it stops right there and returns everything that's extracted so far. So this is just to highlight that point that there's no magic number you're going to put right here, which will work nicely for everyone. This is something we have to recognize. A serious limitation of the left function. Right? When you just want to impose a static number right here for the extraction, it's just very clear that the first names of the customers vary in the number of characters. So this will not work for everyone. Put 6, 7, 8, try out different numbers. There are 91 customers. It's not going to work for everyone. See, for Maria, it has extracted a 5 plus a space. There's a space right here. If I push this to 7, it will cross from that space and pull up the A. So you have Maria A, you see? And then you see it is messing up every other one, except those who have exactly 7 characters in their first name. This almost got through. This is Francisco. See, we missed out on that. See, so that's the issue now. We have to talk about this. Right. I'm going to push this conversation ahead because the function we're going to use in that process, it's going to be something different. So I'm going to skip that. Let's go to the right function. It's the same kind of thing like the left function, but the extraction will be from the right hand side. Right. So I'm still coming back. I'll come back to that process. We have something we're going to solve on that, but we don't yet have the required function to do that. So on the right, I can just copy this. What do you see right here? Len is doing that. This is extraction from the left hand side. In this case of the right function, the extraction will be on the right hand side. I'm just going to change this to right. Right. So we are extracting a specified number of characters from the right hand side. In this, extracting a specified number of characters from the right hand side. Right. So extracts a specified number of characters from the right hand side, right, the right hand side of an expression of type expression right here. Lazy copy paste right here from an expression. And this is the syntax right here. I can just copy this same stuff, take it to the left, right function, right, and just format it around. You see, This is now the right. Sorry, I have to go back here. This is the left function. This will be from the left hand side. And then for the right function, this is correct. Extracts a specified number of characters from the right hand side an expression. Right, so it goes to the right hand side and extracts. Let me just go back and pull up that same example we had right here. So we started off with this expression. Go to this expression and extract the state. The state is this one. So it's on the right hand side. See, so it will be better for me to just go to the right direction. I recognize that Texas is a state, is on the right hand side. Dallas is a city, is on the left hand side. So previously we used the left function because that was an easy way to just go there and extract it. Right. So for the right side, Texas is on the right hand side. Let's use the right function for this extraction. And for us to successfully extract Texas, we need 1, 2, 3, 4, 5. If I put 6, see what happens. It will extract and add a space. This is what it's going to extract. You see, if I run this is the extraction I get. There's a space right here. If you want to see that, you can copy and just paste it somewhere like this. You see that the space. If I reduce this to a 5 and I run this, copy the value, then paste it. The secret is always to paste it on the line and then see what happens. You see, there's no space in that. Right. And if I take this to a 7, it is going to, let me just wipe this. It is going to this. Why? Because that's the right hand side. It goes to the right hand side. 1, 2, 3, 4, 5, 6 is the space, 7 including the comma. So you're going to have this outcome right here. See that? There's a comma, a space, and then it's the comma, a space, and then that. But if you want to just extract this, you have to make sure that you specify 1, 2, 3, 4, 5. If I change this to 5, that will be my state. Right, this is the state is a keyword in SQL. I can just suppress that doing that. See that? So this is exactly what the right function will do. So if you're given a question, you can use left or right, but then always go with what is easy. If I start on this side, I'm going to really confuse myself. But then it is better to start on this side, on the left hand, on the right hand side, and just extract this. It's easy. Before I know it, I'm hitting my target. That's it right there. For the case of the city, since city is on the left hand side, it is better to use the left function, target the left hand side, and before you know it, you're hitting the target. That's the city right there. See that? Right. So those are two, left and right. Now let's go a little bit higher on this by bringing in this function right here. But before I bring in this function, I want to talk about this, the CHARINDEX function. This function is a very interesting function. It locates the position of something. And that becomes very interesting. If I give you a column to split, if you find the split point, when you split at that split point, what is on the left hand side is the first name, what is on the right hand side is the last name. So that's what you get if you're using the customer name, like the question we were trying to build right here, this question right here. If I observe my customer name column, I see that in the middle there is a split point which is a space. The split point is simply what separates the two components. Every single customer name has a space which separates the first name from the last name. If I target that space and I cut it off right here, what I will get on the left hand side will be first name, and what I get on the right hand side will be last name. And that's exactly what this car index function is investigating. It investigates the position of a string within another string. All right, sometimes if you're told to split something, that's what data analysts do. They identify the split point, and when they identify the position, they can now proceed to do the split. You must have a reference. Right? If I go all the way to this point, everything on the left-hand side is a particular component. If I start from this point, everything to this side, that split point is very important. All right, this is very, very important. So that's the concept of the car index function, right? And all of these functions, you find them in W3 schools. W3 schools. All right, let me just take you to that. We are looking at what today we talked about a case statement. You can visit that and just read through. Where did we see those SQL Server functions? This is SQL Server functions. You're gonna see those. We've talked about left, length, right. Yes. Gradually substring. Yes, we're gonna get to that. Where is the car index function? Car index function. This returns the position of a substring in a string. So this function is important to investigate the position of a substring in a string. Right? Any position, you can investigate the position of anything using this function. So this is it. That's the stuff right there. Let's go to Dallas, Texas. See, tell me the position of the comma in this string Dallas, Texas. Tell me the position of the comma in that string Dallas, Texas. You can use the car index function to find that position. What's the position of this in this string? Right. And next, you'll now want to know, hey, but how can we code this to achieve that? Yes, it's going to be through the car index function. Yes, but how are you going to arrange the parameters? Right. And that answer is right. If I click on this, you have to first of all declare the thing you want to investigate. So I want to investigate the position of T in this word customer. Let me just copy this so that we can start with this. Then we now go to our example we're working on. Let me put this first. Go to the string customer and investigate the position of T. So we use the car index function. Take note, this it returns position, the position of anything within the string you're investigating. This is very important. Position, and position is what? Number. So the thing you're going to return is a number. So it starts right here. This is position 1. C occupies position 1. U is position 2. So it's going to read 1, 2, 3, 4. T is on the 4th position. So if I run this, the investigation that is 4. That 4 is just the position of T in that string. This is very important. So the car index function returns the position of a substring in a given string. You can use this to investigate the position of anything, right? So this is very important. What is the position of comma? Position of the comma in the string Dallas, Texas. Let me just search for position of this in the string this. See that? I will use the car index function, and please remember you start by putting the substring before you put the main string. The substring in this case is what? This comma. I'm looking for the position of comma in the main string Dallas, Texas. Look for the position of comma in the main string Dallas, Texas. So if I run this, so this is what the system will do. This is always by default on the left hand side. It's not going to do it from this side. It's on the left hand side. 1, 2, 3, 4, 5, 6, 7. The comma occurs on the 7th position. If I run this investigation, I get 7. This is very, very important. Right? This function is not used in isolation. This function is always used with a substring function. Right? Because the substring function replaces the left and the right function. Right? This function can do the job of the left and the right. Right? And now let me just talk about the left function. Sorry, let me just go back now to the table. Return the position of the space in the customer column. Return the position of the space in the customer column. Since we'll be using search, let's use search for the position of space in the customer table. In the customer table, right? Search for the position of space in the customer name column. Customer name column. Right. So we are back to that TransUnion database. So select star from. I always want to show you the arbitrary one and then I tie it to a table so you can see that in the table we're using the column. This is the customers table. And if I run this, we are searching for the position of the space. Every customer's name has a space that separates the first name from the last name. And that is an interesting point to split. If you want to extract first name separate from this column, and then also extract last name separate from this column, that's an interesting start point. Identify the split position. When you split this at this point, what you have on the left hand side is first name, what you have on the right hand side is last name. So this right here is usually used as a strategy to solve an equation, not the final solution. It's a strategy towards solving equation. Right. So I want to do it gradually. So give me customer ID, and then let's do the investigation. Customer ID. Also give me the customer name. Right, customer name. And now let's bring in our car index function, which investigates position of anything. Car index function is right there. What are we investigating? We're investigating the position of space. And how do we put space in SQL? That's it. Right. Investigate the position of space. And what's the column? This is the column right here in the customer name column. If I execute this, run that, you see that now we can go back and solve that question for extraction of Maria. So where do we stop? Remember, I asked you a question. What magical number can we put right here to extract first names? And none of us could provide a solution for that magical number. But given the car index function, we can investigate the position of the space. Let me show you this. We can investigate the position of the space. For Maria, it's going to be what? This all the way to the space -1. So 1, 2, 3, 4, 5, 6. That's Maria. The space will be on the 7th position. So to extract the 6 characters from Maria, it's going to be space -1. And that formula, we just put it right here. It solves the question. In fact, let me not just explain things. Let me just go back to this. Please record that example, extract first name of each customer from the customer name column. Let's go back now to this logic. We use the left function. Right? Stay with me on this. And this is a little bit tricky, but focus on the logic. Ignore the coding for now. The coding is going to come out. You're going to understand the coding gradually. But the most important thing is the logic. Right? So we use the left function. We specify the customer name, and we wanted to extract first name. So go to the left hand side of customer name, extract. This is where we got stuck. How many number of characters will you put? put 5, I'm targeting Maria and any other person with 5 characters long. See? But then this gives us a clue. The car index has returned a position that is very important. It gives us a clue. See that? The extraction begins on the left-hand side. It goes 1, 2, 3, 4, 5. And then the space is what this is returning. Position 6 is a space. This is interesting. All right, so we can use this as a base. So what if we now say, hey, give me the space minus 1. This is what? Space minus 1. If you give me the space minus 1, we are going to get the number of characters in the first name. Please observe this for every customer. If you find that space and you take out the space on the left hand side, you're left with the number of with the first name, number of characters in the entire first name. If you don't understand that, let me execute this. Stay on this. That's the car index returns the position of the space. That's the space. We're looking for the position of the space. For Anna, it's 1, 2, 3, 4. The space occurs on the 4th position. If you now take 1 away from that position of the space, what are you left for? Anna, we are left with exactly 3 characters. And that 3 characters is what we need to specify on the left function to extract Anna and every other person. This is now the solution to the answer I provide, the solution to the question I asked earlier. What magic number can we put right here, which will return the correct extraction for the first name of each customer? So this is the answer right here. Find that space. Everyone has a space in their name. What is on the left of first of the space is the first name. This is the logic I want you to focus on. The coding, you understand it later on. See? So if you're told to split a column, there's always a split point. And that point is common across every single value. All these values have a space. Let's find that space. This is it. We report the position of that space for every single customer. Now, to get exactly Maria, you need 5 characters. To get exactly Anna, you need 3 characters. So you see that the space is 1 step ahead. If we now deduct 1 from it, we now get the exact number of characters we need to specify on the left function to extract. So I can just copy this and then replace this part right here by that expression, and the job is done. So we're going to be saying that go to the customer table, extract all the way to the space minus 1, and the thing, and report what you have on the left hand side. What you have on the left hand side of the split minus 1 is the first name, and this is it. No mistake, everything works nicely. Everyone's first name has been extracted. This is very important. This is just proof of concept. In a job, you don't need to show this. Dismiss all of this, and this is what you do. Please take note, this is that formula which is now used to magically, calculate the number of characters that should be extracted per individual basis. This is very, very important. It's now dynamic. I want to stop right here for questions. And maybe I provide you with this so that you can explore that, and let's discuss, share this with everyone. This is actually the lecture material I'm building. I'm going to save this, and at the end of today, you will get this. Right, but this is very important. So now we've been able to solve, and this is coming from this TransUnion database project. We've solved question 4. In question 3, we're told to extract. So question 1 was to open the script and execute. We've done this in class. Question 2 was to execute the script. We've done that. That's how we ended up having TransUnion database. Now question 3, extract first and last name from customer name column within the customers table. You have to understand that the customer name contains first and last name. They want you to split it out. So this right here, we're going to give it first name. We are now putting this in a new column called first name. It is no longer contained in the original. This is our first name. See, that's what this question is asking. Extract first and last name from that customer name column. This is what you do for the first name. See that this is using the left function, and you always face this challenge. What magical number can I put on the left function so that it will extract the entire first name of each customer? That is a difficult thing. There's no number you're going to put right here which will do the job. It's never going to happen. You must use a formula, a calculation to get that number. And we relied on what the CHARINDEX function. We launched an investigation to find the space. When you find that space, deduct 1 from the space to get the exact number of characters you need to extract. And this is the investigation. You see, I'm showing you the steps. Right. So we are right here. We want to extract first name. We launch the investigation to find the space, position of the space. This is how you put space in SQL. Empty string. The space in this name, and that's the investigation. You can test. For Maria is what 1. Let's do for Anna. It's easy. 1, 2, 3, 4. That's why we get 4. The number 4 tells you the position of the space. It's 4. Everything to the left hand side of that space minus 1 is the first name. That's a logic to get the first name, and that's a logic we're exploiting or exploring. Sorry. See, this is very, very important. Now that's the logic right here. As we found that space, deduct 1, remove the space so that we can go 1, 2, 3. We stop right there, we get Anna, not 4, because if we go to 4, we include the space. So that's why we're doing the space minus 1. You can easily tell from Anna. The space is on the 4th position. We don't need to go all the way 4 characters to get Anna. We need just 3 characters. So space minus 1. And that's that calculation we're going to put right here on the length function. And it will do the job to extract the first name, which is this. Now, this is very important. And I will just introduce you now to the last function, which is a substring function. This function does the job of the left function. It also does the job of the right function. Right? Why? Because it has a parameter that controls where to start the extraction. You know, for the left function, you always start on the left hand side. That's why it's called left function. For the right function, you start on the right hand side. You see? But in the substring function, it has a parameter that you can indicate where to begin the extraction. Right, so let's talk about the substring function. And during the lab session, I'm going to bring some questions we can look at. So this is a function called substring, and I'll just take you back to W3 schools. On this list, I think I saw the substring function, this function right here. It is the extraction. It does exactly what the left and the right functions will do. Right, so this is it. And I will begin by giving you some examples on that. So that's what the function does. If I just click on this, you see the string right here, extract 3 characters from a string starting at position 1. And the string, the thing is what? SQL tutorial. Let's get this instruction. I'm just going to put it right here. Right. So this is a extract 3 characters from a string. The string is what? SQL tutorial. SQL tutorial. That's the string. See that string is SQL tutorial. The 3 characters we extract is going to be this. Right. You know, since we have this, let me show you the possibilities to solve this question. Possibilities to solve this question, since we want to extract 3 from the left to get SQL, you can use the left function. So, and things you can solve with the substring function, you can solve them with left or right. Since I want to extract these 3 and they're on the left hand side, it's easy now for me to just say, hey, you know what? I'm going to use left, and I just put my string. This is the string right here. Remember the left function, you put the string and then you put the number of characters you extract. The question says 3. So we're extracting 3 from where? From the left hand side. If I put right function, it will come to this side and extract 1, 2, 3. That's not what we want. So this is it right here. See, you get SQL. How will you solve this question using the substring function? Right? A substring function gives you the ability of a starting parameter. So you can specify the starting parameter. Let me see if I can get the syntax. This is the syntax of the substring function. You see, it has a start. Where do you start? And then it has a length. See, where to start and then the length. I'm going to put it right here. This is something we did not see in the left and the right function. They have just 2 parameters, the string and the number of characters to extract. This right here is the number of characters to extract, but where do you start the extraction? That's the power of this function. It has where to start. See, where do you start? So if I want to extract SQL, I'll use the left function because SQL is on the left hand side and it's made up of 3 characters. I get SQL. I can solve this same question using the CHARINDEX, the substring function. I do substring. There's a function right here. So go to this string. See the steps? This is it right here. Put a comma. Where do you start? If I want to extract SQL, I'm starting on 1. This is position 1, position 1, position 2, position 3, all the way to this side. So start at position 1. Right. Then next, where do you end? The length of characters you extract. That's where 3 comes in. So this dictates the start position. You're starting right here, the extraction. This dictates the number of characters to extract. From here, I do 1, 2, 3, and I stop. And that's how this gives you the same outcome. That's why I said whatever you can solve with the substring function, whatever you can solve with left and right, you can use the substring function to solve that same. But the substring function is more dynamic, it's very powerful because of that start button. You can control where to start. You see, I can use substring and I tell the system skip 1, 2, 3, 4. Start at position 5. See something right here. Right. Skip 1, 2, 3, 4, 5. Right. Start at position 5. So I put 5 here as the start. It will skip all of this and start at T. Extract how many? I want to extract tutorial in full. So 1, 2, 3, 4, 5, 6, 7, 8. If I change this to 8, you see, this will skip all of this, including the space. It will start at the 5th position. T is in the 5th position. 1, 2, 3, 4, 5. It starts at the 5th position and extracts 8. I get tutorial. This is something we can solve using what? The right function, because tutorial is on the right hand side. This is how you solve that same question using the right function. Use the right function. Why am I using right? Because tutorial is on the right hand side of that string. I go to the string, right? And I just simply specify the number of characters to extract. Put a comma. If I start on the right hand side, I do 1, 2, 3, 4, 5, 6, 7, 8. I'll get tutorial. So if I put 8 right here, I'm getting this. So this is just to prove that whatever question you can solve using the left function, you can solve that same question using the substring function. Whatever question you can solve using the right function, you can solve that same question using the substring function. Right? It is very powerful because of this parameter with the start. It controls where to begin the process. Now see how beautiful we can use this in this question of searching, of getting the first name. Extract first name, this one. See, we can use the substring function to solve this question. Nice and easy. Extract the first name from the customer name. Let's just dismiss this. And let's begin with substring. Let's first of all discuss the strategy. That is the most important part of this strategy. If I take you to first name, instead of just talking on the column, let me just copy a certain first name and just put it right here. I want us to have this conversation. Please stay with me on this. See this name right here? I want to use a substring function. I'll target this column. Where do I begin extraction? From position 1, which is this. Where do I end the extraction? There's a space right here. I end it at the space -1. This is very, very important. And that's the strategy to extract the first name using the substring function. Begin at position 1. Please remember, substring function has a start and the number of characters to extract. I begin here at position 1. I start the extraction. Where do I end? I go to the space -1. This is first name. How can you code that process I just demonstrated? Start at position 1, extract. Where do you end? End at the space -1. That's it. What I've demonstrated right here is what the substring function can do. Go to position 1, start the extraction, stop at the space -1. That's what? First name. If you want to extract the last name, start at what? The space +1. This is a space +1. Start right here. Start at this space +1. Extract all the way to the end of the string. That's how you're going to extract last name. Again, we are just using the power of the substring function, the ability that you can control the start and then the length of the extraction. The left and the right function have this one, but they don't have this one. See, this is very important. That's how you're going to extract first name. I start right here, extract all the way to the space -1. That's my first name. For last name, I have to skip all of this, go to the space +1. This is a space +1, so that you begin right here and then take it all the way to the end of the string. That's it. Let's do it step by step. So let me just put the comma right here. Call your substring, and then a lot of students have just ignored the left and the right function, and they're just dealing now with the substring function because it does things in a very smooth way. That parameter, the presence of this parameter gives you a lot of flexibility. I want to extract last name. I can skip all of this and start at the space +1. That's my starting point, and I extract all the way to the end. If I want to extract first name, I start at position 1 and I go all the way to the space -1. You see that? That is it. And so let me put some requirements that I will need for this question. Right? I will need the position. Before getting to the substring, what do I need? I will need the position of what? The space. And from our conversation previously, the position of the space can be investigated using what? The CHARINDEX function. So I'm just putting the requirements we'll need in this equation. So what are we investigating? The space. This is how you put space in SQL. From what? From the customer name column. Right? I want to start by gathering my requirements, things that I'm going to need. And you can always stop right here and test the stuff. It is showing you each customer full name and the position of the space. Please take note, to extract the first name, we need to go from this position all the way to the space -1. So that's why I will stop right here and deduct 1 from the space. We don't need the full stuff. We need just all the way to the space -1. See Maria, all the way to the space -1. That's Maria right there. So that's what we've done, all the way to the space -1. See, so this is very, very important. That's it. Right. And then now we are ready to bring in what? The substring function, because now we have every requirement. The substring function tells you go to a certain column. This is a column. We want to extract what? First name. First name is right here. So we begin at position 1, right? And then go all the way to what? This, the space minus 1. Start at position 1, go all the way to the space minus 1. What is space minus 1? This is it right here. So this is us starting at position 1. Where do we end the process? Space minus 1. That is how you provide the 3 parameters for the substring. The string you want to work on, the start position is 1 for the first name, all the way to the space minus 1. So you start right here, all the way to the space minus 1. Every single value will fulfill that requirement. I always like to isolate certain values so we demonstrate them. When things are on columns, it's very tricky to see. Start here at position 1, this is a meaning. Go to this column, that's the value I just put right here, this is it. Start at position 1, there's a meaning of this. All the way to the space, that's the space right here. All the way to the space minus 1. What do we get? Anna, first name. Start at position 1, all the way to the space minus 1. What do we get? Maria. It's the same for every other customer. That logic will not fail. Start at position 1, go all the way to the space minus 1. What do you get? Antonio. Doesn't fail, and that's how you code that process. Guess what? This is it. It will never fail you. That's it. And that's what that's the first name. Right. Sometimes this thing feels like rocket science, but you have to create time and then watch the video again, follow this explanation and interpret and then code it. This is very important. This is just for demonstration, but then this is where you're gonna settle your work. See, if I can just put that its face is gonna be this one. You no longer need that part. Just dismiss this. Right. That is how you end up extracting first name from the customer name. I have to stop right here so that you guys can understand this before we look at the last name. And the same process we're going to do for the last name. We're still going to use the substring function. All right, I will explain the logic of the last name. But first, let me give you this right here so you can play around with it and see areas where you're going to need more explanation. We can address it. Let me just paste this right here. This, I'm going to give you a couple of minutes to go over this. Extracting the first name from the customer name. In this case, we are using the substring function. And this is the syntax for the substring function. And I'm just going to put it right here so you can see the flow. Okay, guys, if you're ready, I want us to repeat this same question for the last name. All right. So I'm going to switch this to last name, and then we're going to discuss the logic so that we understand. So extract the last name from the customer name. We're still going to use the substring function. So I'm going to copy this setting right here. I'm just going to dismiss every other thing except the customer ID and the. Right, so this is what we have. We're going to use the customer name to extract the last name. Now, these are some very key things I want us to discuss. I'll take a sample of maybe the first 5. Just copy the values and put them right here. Right, and you'll notice something that will be common in the strategy. We're going to put in this strategy, I will be using the substring function. We know this part is going to be what? Customer name. This part right here, if you want to extract last name only, where should you begin? And I always want to point you to a typical example. I want to extract just the last name. Where should I begin? I have to skip all of this. You see? And I should begin at the space plus 1. For the first name, we started at 1. This was easy. See, first name, start at 1. Extract all the way to the space minus 1. For the last name, you have to skip and begin at the space plus 1 and extract all the way to the end. See, it's the same for every scenario. Skip, go to the space, add 1 to the space so that you begin. If not, you have a space in front of the last name. The space in front of the last name. You see, that's why we are adding 1 to the space so that we don't have this scenario, but we rather have this scenario. This is very important. This logic I'm explaining, that's the power of this. All right, we are using the substring function. Where do you start in order to extract the last name? If you use the left function, you can go to the left hand side and just extract. But then now you always have to play around. Where do you end? You start on the left hand side and extract. Where do you end to get the last name? See, you can still use that space plus 1 to end. But then in the substring function, yes, you can make it easy. Start at the space. That will be your start point for the extraction. The space plus 1. Space plus 1. You start right here and take it all the way to the end of the string. That's where some key definitions will come in for us to solve this. The end of the string, that's the length function. Right. So I'm going to put some key definitions right here. Let's find the space plus 1. So how do we look for the space? Char index plus 1. Right. Now I'm defining the components I'm going to use for the substring function to extract the last name. So char index helps me to find the space. I need this space. Every single one of these customer names have a space. That's a very good split point. When you can identify something that's common across the board, you can use that as the split. So find that space and add 1 to it so that the extraction should not have a space in front of the last name, space in front of the last name, space in front of the last name. We should rather have just the last name. So achieve that by doing the location of the space, which is this right here. This is us locating the space in each person's first name. See, for Anna, this is what 1, 2, 3. We get 3. Where's Anna? Space 4, sorry. Right, 1, 2, 3, 4. That's the space on the 4th position. For Maria, the space is on the what? 1, 2, 3, 4, 5, 6 position. See that? If we don't remove that by adding 1 to the space, you're going to extract people's last names and there will be spaces in front of it, a space in front of each last name like this. This is the extraction you'll be doing. So now we know where to start. We're going to start on the space plus 1. This is very important. Please remember, you have to understand this. I don't really care about the coding, because in an interview, this is what you explain. Yeah, you not really go deep in coding. Yeah. So you have to understand this. And guess what? In a data analyst, we just go to Google and search things. But then the most powerful tool a data analyst needs is a logic. And then implementation, you can go to Google and find the code and implement it. Right. So strategy is very important in a business problem solving. This is key. Right. So that is me now returning the space plus 1. This will now be my starting position in the extraction. See, I'll start on the 7th. So for Maria, I'll start at the 7th position. If you count, right, let me just use this one. Oops. This is what? 1, 2, 3, 4, 5, 6, 7 position. I'm already at A. So I start at A and extract all the way to the end. Now the concept of all the way to the end, that's when you can use the len function. Right, and it take you all the way to the what? The len will give you now the full characters in this string. So start in this position and take you all the way to the end of the string. That's the len of that string. In that case, we do the len of what? The string we are investigating is the customer name. You see where the len function now comes in. So I've put these two criteria. So Maria Anders, there are 12 characters in Maria Anders. I will begin at the what? The 7th character, and then take it all the way to the 12th character. That's how I extract last name. For Anna, I will begin at the 5th character, that's T, and take it all the way to the 12th character, and that's how I fully extract the last name. So these are the two components I need for my CHARINDEX function. Sorry, for my substring function. The start position is this, and then the length, the full length of the string. When I start at this point, I take it all the way to the end of the string. That's the full length of the string. So if I put these two together in this logic of the substring right here, I will be able to deliver. So on my substring function, I am going to my main string, which is what? Customer. Go to the customer column, begin extraction on what? The space plus 1, this right here, space plus 1, and take it all the way to the full length of the string. What is the full length of the string? This is this part, and this is what we are seeing right here. And this constitutes the components of that substring function. And guess what? If I run this, I will nicely extract the last names. And for each of these last names, there are no spaces in front. Just how do you know if there's a space in front of a string? Just copy the string and just paste it. You see how I've pasted this one? Just paste the string. You see it aligns nicely on the line. Now let me show you proof of concept. If you go and remove this part, you also remove this part. What are you doing? You're extracting from the space all the way to the end of the string. And this will give you spaces in front of the last names. Let me just extract the first 5. That simple test, paste it on the line, and you see it aligns a space before the last name. So now you understand why we are finding that space using the CHARINDEX function. That's a space, and we are adding a plus 1 so that it goes to the first character on the last name. So there's a need for a plus 1 to be added right here, and there's a need for a plus 1 to be added right here. Right, so that if I run this and I copy and do that primitive test I did previously, which is this, comes in very handy. Just paste it on the line. Let's go back to the line. That's the line. Paste it. You see, it stays on the line. This shows you that there's no space in front of the first name. But the previous example had spaces in front of the first name. See? So this is very important. That's it right there. And that's how we've nicely been able to extract the last name. And guess what? I have to just put the name of this column as last name. Right here. And now we don't need, the last part will just be the actual stuff. We don't need to show this in the final result. This is what we're going to be getting. And now I'm going to share this with you all. Now, this is the title right here. I will, of course, let me save this. So this is data extraction functions. I'm going to save this. Please, you have access to this. All right, this is data extraction function, data extraction. All right, and this should go into A1 data extraction functions. Now, if I, oops, what happened? It's complaining about this. See this? Some Unicode characters in the file could not be saved. Yes, so it's complaining about this is not a SQL concept. It's because I copied from X from PDF and I pasted it. Those things showed up. Yeah, I'm just going to save it like that. Okay. I think last time I saw this in this database, we are looking at this online tutorial. We're looking at, there was learn SQL. This is under string functions. So these are math functions, date functions. We've looked at the case statement. I'm going to show you the database for that during the lab session. Window functions, we're going to see this tomorrow together with the ranking. String functions, yeah, these data extraction functions are always treated under string functions. So they should be, I'm going to update this into string functions. But now the sub part that we'll focus on right here is the ones that do data extraction. Under this criteria, you're going to see upper, this has, we've done this one, string functions. Now this is extraction, extracting substrings with left right function. See that? So given this string right here, extract 7 characters from what? The left hand side. That's how you read this. The string is Captain Marvel. Extract 7 characters from the left hand side. This is the left hand side. Start 1, 2, 3, 4, 5, 6, 7. So the left sub gives Captain that. Now on the right, go to the right hand side of this string, which is this side, and extract 5. 1, 2, 3, 4, 5. You have this. All right. The len, this is PostgreSQL. It says len. In SQL, we don't type it in full. It's a short form. It's still looking at the number of characters in a given string. For example, this word or this string hawk has how many characters in it? 4. So for this, you use a len function. You cannot run this in SQL Server. This is very important. See this right here. You cannot run. Yeah, this one you can run in SQL Server. You see this right here? If I copy this, I can run that in SQL Server because the two agree. Postgres and T-SQL agree on the left and the right function. So if I paste this, it's going to go through. If I execute, it will go through. So we went to Captain Marvel. We extracted 7 characters from the left-hand side, and I demonstrated this. Count this. This is 7. Stop right there. That's what you get for the first column. Second column, we are using the right function on Black Widow. We are going to the right-hand side, which is this side, and we count 5. We get that. See? Now, if you want to practice this one on the len function, if you copy this, you see I'm copying without the from clause because I don't have the table, right? But then the string is embedded, you see. This right here, if I execute this, I get an error. Because in T-SQL, the correct function is len, not the full word itself, you see. So this function will simply go, this is what we'll study today. That's the first function we started. The len function counts the number of characters in a given expression. This is the expression, count the number of characters in that. That's 4. It's another one, count the number of characters in that. Of course, you can do that, see, 4 and 11. So this is just a review of the functions we've done today. We talked about this last time, removing spaces. Right. Now, we've not talked about this function. I'll come back to that. Yes, I'm going to come back to that function. Right. During the lab, I'll come back to that. We've talked about the concat function. We talked about that. This is substring. Yes, this is what I wanted us to talk about. So I can just copy this without the table name, right? And I can put it right here. So we can just go over it. See? Substring, substring. So why am I getting an error? I did this comma, substring that. Okay, so there's an issue right here. If I forgot to put the substring, I'm just gonna dismiss that one. I'm gonna dismiss that one. Remember when we talked about the substring function, you have to specify 3 of those. If you look at the syntax 1, 2, 3. So that one had 2 with a negative, it doesn't support negative. Right. So this is what I was trying to demonstrate. Right. And also in this one, what are we using? Positive index. Right. So this is the correct one. See, every other one is giving you an error. Let's run this one and see. Negative values are not allowed on that. So the only correct one is this. It has the 3 required things to do. All right. This one right here works. It goes into Spider-Man beginning from the first position. This is what this means. 1 and extract 6 characters. 1, 2, 3, 4, 5, 6. You get Spider. You run this. All right. Anyway, you can practice this and the explanations follow. Let's look at the scenario where you have a SQL interview question. Right, you're going to see a lot of these have case statements. Case statements, extractions. Yeah, so during the lab, I'm going to bring you questions so that we can go over them and test this concept. There are a couple of functions I've not yet covered. Yeah, but the focus for today, let's go back to the objective for today. The objective was to cover this, which we've done, and also this. And then tomorrow, the focus will be on window functions. I don't want to bring anything tomorrow, so we're just going to do strictly window functions. This right here. All right, this is also a very important topic. Right. And then every other function we've not covered, I will create time during the lab session. We can go over it, or maybe next week. Anyway, let's just focus on the lab. Next week, we're going to address that. So tomorrow, this discussion will be strictly on window functions. All right, this is very important. This concept of window functions is very, very important. Just a moment, let me take you to LinkedIn. So please, nobody should miss the class of tomorrow. Window functions, that's a very important advanced topic in 67. All right. It will always show up during interviews. I just want to show you some important online posts Yes, so tomorrow, this is what you're looking at, window functions. Right, so we're going to see that. And this is another one right here, popular SQL interview question. What's the difference between rank and dense rank? And in the topic for tomorrow, you're going to see that featuring window functions. That's when you're going to address that concept of rank and dense rank. It's always showing up in interviews. Right, so this is very, very important. This is the one, this objective. Yes, we're going to see window functions tomorrow. Only window functions, just this segment. This is very important. Right, and that concept of roll number, rank, dense rank, these three are always asked in interviews. Right. So tomorrow we've seen aggregate functions, but then we're gonna look at it in the perspective of a window function. And what are window functions? A lot of the examples, this guy right here, this is the gentleman that is behind this website. This website we keep going to and looking at the lectures and interview questions. This website, the lectures, this lectures is built by this guy. So when he's posting things on LinkedIn, people take it very, he has worked across different companies and he understands this. See, all right, so window functions, they're this layout right here. We're going to address it. All right, and this interview question by the end of tomorrow's lecture, you should be able to explain this in an interview. You see, popular SQL interview question. What's the difference between rank and dense rank? Okay, yeah. So tomorrow we understand what we're going to be doing. Any question before we go? Okay, guys, see you tomorrow. I will upload the video once it's ready, and I'll also attach this lecture material right here, which is focused on string functions, but specifically the data extraction functions. Okay, so see you tomorrow.
Yeah, thanks, Ashok.
Okay, Lanita has a question.